Hello, hello. Let's see. Do I have like a to-do? Yes. I think I'm just gonna write down what I'm gonna work with today. I'm a little bit sick today, so I might not be on here for too long, but I just wanted to make some progress. And okay, so last time we did LSP stuff and also tree sitter highlighting. Oh yeah, I remember now. There was a bug. So the LSP is up and running, and it will tell you about errors. If I start it here, you can see, okay, since we don't have support for this yet, so that's why there's an error here. But as soon as I change something and yeah, you can see obviously it doesn't update. Also, strange how it if I run this, okay, the LSP should be, yeah, it's active now, Runic LSP. However, if I do a change now, I insert some text, it's gonna quit with some error, and the error is happening because if we go to the LSP server and we go to this part here, so I think it's because this doesn't work. So what's happening is that the LSP client is sending a document did change, or text document did change, and then we go in here and then everything here works, and we get this range change, which has a start and an end on the range, and then the change also has text and range length, and so we store all that in an object. When we get that kind of update, and then we go in here and we get this text update thing, and the text update is either a text or a range. If it's a text, then it's just a full replacement of the whole document. If it's a range, we just edit the document where the range is. So we will find the start index, so we find the start of the text, and then we try to find the start of the text. I think that's the issue here. It's like it's not really finding the start. Also, I think maybe we want to store these as a list of lines instead of just a text, because that's how this is conveniently working here, it seems. So, however, yeah, then we need to, like, when we parse the code, we need to kind of, well, either we could work with lines, I guess, or we could join them, I guess. We could concatenate them. That's not a huge deal, I guess. either. But basically right now we're just storing everything as a huge string, the whole document. And we're trying to find the index in there. And how we do that is we have we store like the column and line. This is like the algorithm here, and the index. And then we're checking until we have column. Well, while column is not equal to character and line is not equal to line. So if both are equal, then this expression is false, right? Because if this is equal, then this is false. But then this is and wait, is this wrong? Hang on. So if this is not equal, this is true, right? But as soon as this becomes equal, then we jump out. Okay, this is wrong. Hello, Rookie 2K. How's it going? This is wrong, I think. It should be or, right? So if the column is not equal, this is true, and then we should still keep going. Yeah, okay. Maybe that was the issue. Okay, it's not crashing anymore. Now it crashed, okay. But it might crash for something else. Yeah, range not found again. I think also Neovim is like it's sending an update for every keystroke or key press, which I'm not sure if I agree with that. Good morning from Boston. Isn't that like super early or middle of the night there or something? Or is it somewhere else? Maybe? Is there a place in like the UK or something that is called Boston? Sorry for my ignorance. 1 second, I'm just gonna get my breakfast out of the oven here. Oh shit. Just fell over. Oh well. It's 3 AM insomniac. Oh. Sorry to hear that. Alright. Oh, man. Have you tried counting sheep? Does that work? I think I've tried it once or twice, but it never really worked for me. Wait, right fail. Wait, right failed. What do you mean? Oh, it's not the error, it's just the line. That's it. Okay. No, it doesn't. Okay. That's too bad. Okay, this is just a bunch of leaks. Where's the actual error? It's so hard to look at this. Yeah, error range not found. So, yeah, the whole range thing doesn't work. I'm contemplating. I mean, it should be possible to make it work. Though I am contemplating to maybe restructure the document to be like a bunch of lines instead. But the problem there then is that then you need an algorithm for updating multiple lines at the same time. So kind of just shifting the problem over. Although it arguably could be more optimized for some of the operations. Well, whatever. Let's just see if we can figure it out here. Unless... Yeah, this is their change. So we're getting character 5, line 7, character 5, line 7. Range length is 0. So it's basically an insert. I mean, technically, we could make that into a separate, like if we can see that the start and end is at the same index, or the same place, we could make it an insert instead. Maybe. We should be able to find the start though, and yeah, it should be, you should be able to use the same algorithm for the same thing. Range not found 5 series 5 7. Maybe we'll print out this line and see what we're thinking it is. Like, we'll take like so like range, no. What is it? Text update, location find index, and we'll find like character 0, line is gonna be range start line. So this should definitely be able to be found. And the source is .text. Okay, so now we should have the start of this line. Let's make this, okay, so actually start line n is going to be range start line -1, but we're gonna do like this to guard against overflow or whatever it's called, underflow. I don't know if it's like going below 0, and then we want the end line. I'm just gonna add 1. So we'll capture like the lines around, so we can get some kind of context there. Maybe even more, right? And then we have the start. So the start index, it shouldn't actually shadow here. That would be very silly if this was shadowing. No, I don't think so. And then this would be like start line. And then we have like the end index. Line is going to be end line plus 1, I guess. Let's do this for now. Okay. Okay, so we have start and end. Actually, maybe we want a thing that finds the line. Line of the source and we could just reuse this here. You could also use an iterator, but we already have this algorithm here, so I'm just gonna use this. And then we have like the end. There should be something like index of scalar position, start index value, and then something like this. And this could be null, so if it's null, then it's we should just get, yeah, so basically if we have the end, we use it, otherwise we're just gonna do this. So we'll take the last part. If this is null, then we have to return null because we didn't find the line. Okay. And yeah, as I said, another way to do it is to make an iterator. Maybe we should even do it instead of this thing here. But yeah. So let's see. So let's do like actually, yeah, that's the start, and then we have the end, and then we'll do like lines is gonna be an array of up to 5, I think, strings. And then lines n is gonna be end line minus start line. So that's how many there are, like lines length. And then we can say this not found, and then we can do like loop lines length, and we get the line is gonna be get line I plus, no, it's gonna be, yeah, it's gonna be start line plus I, and the source stop text. If we don't find it, maybe this would be like not found. And then we'll log error line something, and then the actual text. This is we don't actually need the array. There we go. All right. So hopefully this will give us a little bit more context on what's going on. Yeah, there we go. An error. Range not found. Okay, so where is... hey, is no chance at some point you show us how to use new Zig async for starters? Well, I haven't actually used it, so is it? I mean, is it even out? Last time I checked, there was still. Okay, I'm gonna check releases. No, we're still on 0.15, I think. But I guess, I mean, if you're using the latest, like the master version or something, I don't know, there is like 0.15.2, but that seemed to be like, yeah, I don't know, it doesn't have any updates, notes or anything. Yeah, but I think async might come in the next version. So I haven't looked at it, to be honest. I mean, well, you could look at, like, I guess, the documentation, like the talks and stuff about it, but one second here. So if we look for like async, yeah, async functions regress release L.11. Current plan is to reintroduce them as lower level primitives of Power IO implementations, tracking issue. Yeah, so it's like right now, I'm not sure what the status on this is. milestones. Yeah, I don't know. To be honest, sorry. But it's, I mean, it's not gonna be released. But I mean, there, yeah, as I said, there might be some documentation and stuff out there from how it's supposed to work, but there's no actual. I don't think there's any like actual working. Wait. What about, maybe it was closed already, sorry. Yeah, this is the milestone. Closed. Is there anything with async? I mean, it might have been in 0.15.2, but I don't see anything. Oh. But there was something here. Yeah, here. This is the only one referencing async. And it seems to already be something, so I don't know. Also, why is this lowercase? That's like the old. That's something else. IO. Oh, so it's like IO async. Huh. Wait, so there is something there? No. IO async calls function with args such that the return value function is not going to be available until wait is called. So it's just a function. Idempotent, denoting an element of a set which is unchanged in value when multiplied or otherwise operated on itself. By itself. Okay. So like, is this the same as like 1 in multiplication? Or I don't know. Yeah, I mean, you have this, I guess. This doesn't exist right now. This is new, I think. Because I'm trying to look at standard IO async. There's no async here. So this is new. But it doesn't seem to be part of the language per se. It seems to just be a function here. Which is cool. Well, what's the arguments? Function with R such that the return valid function is not guaranteed. Okay. Function. Oh, I see. It calls any function. So it takes a function, and then we supply the args as a tuple. Oh, nice. Args tuple. This is pretty cool. I don't think this has existed before. Args tuple. Oh, it does exist. Okay, I've never seen it before. What about return type? No, that doesn't. Yeah, you have to do this. Why can't they just add a return type? Return type, you know, same as this, except it's like return type of function. That would be so convenient. Anyway, so and very easy to add. I mean, it's just this basically, I guess. Okay, so we got this types here: result, args, type erased. No, I haven't looked at Andrew's post. Alright, cool. So that's in 0.16. That's in master right now. If you want to play with that, you could go and use this. I'm assuming since it's in the documentation right now for the master version. I thought it was gonna be like a new language construct, like you know, a keyword, new keywords, but yeah. Anyway, okay. Let's see. Okay, one thing I need to fix here. Server. No, this should be like new lines. Yeah, it should say range not found, and then immediately after it should log these things as well. So I don't know why it's not doing that. Oh, here we go. 7. Okay, range not found. 5, 7. Hang on. Wait. Yeah. 5, 7. So this is. I was confused with my search here for a second. Why does it start at 7 though? No, it doesn't. Okay, it starts at 5. Okay, 5 is this comment here. Is that correct now? Line 5. It's actually, well, it's zeroing the index, I guess, so it would be like 0, 1, 2, 3, 4, 5. Okay, so that is correct, I think. Yeah, and then 6 is the empty line. 7 should, yeah, okay, so 7 is function h, so this is the place where it tries to find 5. 0, 1, 2, 3, 4. Yeah, so it is the correct line, but the column is wrong. Or I mean, yeah, we didn't get, I guess we didn't find, or maybe we didn't update it yet. There's some continuity issues, maybe, I don't know. we're inserting H, and here we're inserting E. And that's where it goes wrong. But what the hell? Wait. Hang on. Received message. Start at 47. End 47. Text E. Oh, there's multiple. Oh. I see. It's like batching. Okay. Okay. Good. Because now we know what the issue is. Okay, cool. Did change. Okay, cool. So we have to support multiple ranges, like multiple updates. Yeah. See here, we're looking at the changes here, and we take just the one. This is, by the way, AI. I'm blaming AI here because that's what it did here, and I just okay. Well, maybe there's like some sort of capability that only allows one item. I don't know, but apparently we need to check everything here. So we actually want to have instead of one text update, we need text updates, and we're gonna do. That and change value. No. So, well, okay, changes. So we're gonna loop through changes. And then we should be doing the same thing here. Change value. Wait. Expect object. No, this doesn't work. You are the value here. Okay. There we go. Okay, items. There we go. You're the value. We're expecting this to be an object. We get this object here. I really should change this to like a JSON deserialization instead, but this is what the AI did, like this weird like expect object stuff and whatever. I'm gonna change it later, but right now I just want this to work here. So let's see. So we get the change now as usual. Instead of doing this, we want to do append. I mean, we do have the length, so we could do like init capacity, or we could even we could do init capacity. With the length. Does it work with try? I don't think it works with try, so I have to. Well, I guess we can do this. Yeah. All right. And then, so that's going to be that. And now we can assume capacity here. And same for you. Okay, and now we pass in this instead. It always trips me up why this is like could be an error. Old memory. Remap. Caller owns return and empties array list. The capacity cleared. Making the unit safe but unnecessary to call. Like, why couldn't this just set length to 0? And no, wait. Yeah, and length to 0, and then yeah, isn't that, or capacity to 0? I mean, couldn't this just set capacity to 0 or something, and then set the pointer to undefined? I don't know. Maybe they, yeah, there's probably. I've been like, every time this happens, I have to go in and look why this is happening, and it's not clicking for me right now. So let's just move on. Right, so you don't want this, you want a thing. So let's change this. Text updates. All right. And we have to deallocate it, so we'll free this up. I mean, actually, it's probably better to do it here. To use the same. Whoops. Yeah, so then we can, okay. Because we're using the same allocator, and then this doesn't have to be like 2 on slice. We can just say text updates items instead. There we go. Right, and then I guess we just loop instead here. And instead of referring to, so this, instead of referring to doc text, I guess we would use this. However, let's do a dupe. And we'll loop through the text updates. Whoops. Text. Yeah. So we're constantly like setting this. However, also we should, yeah, okay, so we do need to like, man, okay, every time we enter like, okay, if we do this, we should also deallocate the previous text. So we're freeing that, and then we're duplicating that, yeah. And here we should do the same thing. However, this is kind of weird because we're, okay, let's just, I want to do this after, because I guess technically it could be like invalidated, or yeah, this relies on itself here. So couldn't we then make old text equals text? Okay, so this is a copy of the slice, and then we free the old text like this. That should work, right? because this is an entirely new position. This is an entirely new pointer here, and I will keep the old slice intact with the length and everything because allocator is using that. So we can do this. Okay, so then every text in this every iteration, this text should be deallocated. So that's good, and then we will end up with the result. Which we set the text, which in this case has this algorithm here where it frees the text and then duplicates it. Wait, shouldn't we duplicate first? Okay, maybe it doesn't matter because we're not touching the memory. This is not a multi-thread or you know, but it just feels weird. No, wait, we're freeing self.text and then we're duplicating. So we're not freeing the text. That's why we get all these leaks. Okay, well, let's free it here, I guess. Okay. Alright. So now we should take in multiple edits and apply them one by one. But yeah, it's highly unoptimized, this code here. But because we're not really, what we could do is reuse the same like memory area and try to like increase it if we get more text in there. But if it's decreased, we should keep the same area so we don't have to reallocate it. But yeah, anyway, this should work at least, I think, hopefully. Oh, hey, no crash. If I delete, it still keeps the same diagnostics. I'm not sure what we can do to clear it. I'm just eating. All right. There we go. Now I'm done with that. Okay, nice. We got past the issue. Okay, so next step here is like, okay, how? Because what's happening is basically we're gathering all the diagnostics and we're sending it. But as we send the diagnostics, we also clear the diagnostics on the server. So we're basically flushing them out. And at the end of it, we don't have any diagnostics left. So the next time we get an update of the document, I thought that like you have a version, and every time you have an update, it should increase like the version of the document. And so the diagnostics for the old version doesn't apply anymore. That's what I thought. Maybe it is that way, and maybe we're doing something wrong here. But let's see. We have like did change, for example. and we get the version from the text document. So this should be like the new version. If we go to LSP log, and here's, for example, version 33, which you can see here. Here, version 33. Do we have like... No, this is like yesterday. Yeah, so here's how it works. Like, okay, so basically we get the document is version 0. The user edits the document. NeoVim or the LSP client sends did change with a new version. And then the diagnostics that you return have to match the version of the document. So what I'm gonna do is I'm gonna wait. I'm gonna do here, so I'm gonna say, okay, we're sending these diagnostics. Now I'm just interested in how many. And perhaps the URI, I guess. Whatever. So diagnostics length, version, and URI. And then the version needs to be that. Okay, so if we do this, now we can see what diagnosis is gonna send. Also, another thing I want to do is yeah, this is happening everything. So the workspace, like, it reports diagnostics. The thing is, this does a scan route, refresh. Like, the thing is, this, I don't want this to do what it does. Basically, what's happening is when you load up the LSP, it's gonna like scan all of the files in the current directory, and then this is the AI that did this, and then so it walks through all the files with our script, like, language name and or extension, and then it runs a parser on it, or it runs like diagnostics on it. So we don't really want to do that, actually. Well, I get, yeah, it's like collecting symbols, which is fine, I guess, because at some point we probably want this, because we could like tell the LSP that, hey, we want this symbol and it might exist in some other document. So if we collect this symbol, this might be a way to like quickly import something from another library or something like that. But for now, I don't think we actually want to do this. This index file is this is basically the only thing it does. It like collects the symbols, it parses the file. However, by parsing the file, we also report diagnostics, which could be fine as well. I mean, but the thing is, we probably don't want to see diagnostics until we open a file and then see the diagnostics that's related to that file. Is probably how we're gonna do it, because we're not gonna have like a project folder with, you know, descriptions of the project or something like that. It's gonna be a scripting language, so you're just gonna create a script that is gonna be, you know, alongside another project in another language or something like that. That is gonna be a helpful tool to run some code, basically. So that's what the purpose is. So we don't really want to do this whole thing here. But what we could do to just disable this for now is we could, when we flash the diagnostics, we could skip the whole workspace stuff. So let me make flash diagnostics, flash workspace diagnostics. I see. We probably, yeah, we want to populate this group. That's what we're trying to do as well. So let's just add this. And that's fine. I guess we could call this like group. Groups. Yeah. Just like that. All right. And then this could be for documents, so groups. And we will take all this, put it here. There we go. And then do group documents diagnostics. All right. Then the rest should be the same. So here we basically just disable this part, so we don't include that in the result. Now this might solve the issue, but I just wanted to do that first, so we don't get all these reports that we don't want, that we don't need. Interesting that it doesn't report until I pressed escape. Not sure why that happened, but okay, it does seem to update now, but it doesn't update there. Well, because if you add a Windows support, so it will be possible to make a build system using a programming language. Yeah, maybe. I mean, there's. I'm not sure what's preventing from actually. Like, you could clone this and build a Windows version. Like, let's see. what is it called? Like Windows something X. Yeah, something like this. I'm not sure what exactly it's called. Or is it this? Or is it Win? No. Build, help. I thought there was one option you could take to show like what are the supported targets or something like that. Oh. Okay, so it's x86 underscore 64 hyphen Windows. There we go. Okay, this main implementation dispatch run. Okay, REPL 284. Oh, I haven't actually done this flag or interesting. Okay, so I never saw this. I'll just do this. Yeah, the REPL doesn't work. So it doesn't matter that much. Restore terminal. Man, how many of these are there? Tracing? Yeah, there's probably ways to fix it for all operators, but I'm just trying to make the interpreter work. That it should work, I'm pretty sure, on Windows as well. There might be something blocking it, but I'm not sure what's going on here. This is iWriter, okay. And what's the invalid format string? Oh yeah, so this should be like, okay, so this would be in command runner 175. It's weird that it would only be picked up in Windows. That's super weird. How? I have no idea. Maybe we do have operating system dependent code here. Oops. Yeah, the AI produced a lot of old style code. Please be the last part. Yes. Okay. So now we should have a Windows executable. And we can run, for example, this file here. And okay, so we get the same error. So yeah, so it does work for Windows. You just need to compile it for like the Windows target. Not sure about the LSP though, but no. Yeah, I mean it seems to work. So yeah. There's something wrong with this script here. I think it's this one. Yeah. So if I run, I mean, I should have exe in path as well. Oh, file not found. Okay, there you go. There's some issue, but I think that is because like it. Okay, that's because the file is not accessible in this file system from Windows. Maybe it did, but it did work before, so that's strange. File not found. Now that indicates that, oh, it's probably grep or printf. Yeah, this doesn't work, of course. Right, because we're running it on like Windows. But if we do this and this, no. Okay, 17. What do you mean file not found? Does echo not exist? Not exist? Oh yeah, that might just be like a PowerShell thing. Wait, shouldn't that exist? Maybe that's not a program. Maybe that's just a, I don't know, command line construct or something. What kind of program could you use in, like, is this a thing? Or that's so strange, like PowerShell and another thing, CMD, they don't use, it's not the same thing. But you would be able to run some kind of executables here. I'm running compiler, my compiler was not working correctly because long int on Linux and Windows are different sizes, and I casted it to i64 and was trying to generate assembly using it. Okay. So Windows were generating garbage for literals. Okay. So, but do you... do you have to clear it in the casting process? The upper portion. That's not... But if you clear it, you have to... okay. I mean, wouldn't it be possible to... I mean, okay, I'm not sure how your program looks there, so it depends. I guess. Let's see. Okay, let's try and make this work here. So, all right. So the problem now is that when we type this, we get the error because this is expected, this error here. So that's good. And then but then if we do this, okay, let's look at the logs. So we're down here. Okay. And then I do this. Okay. Did that send any kind of message here? So we received the message did change. We got a did change, which says content changes range start character 0 line 6 and character 0 line 8. Range length is 20. Text replacement text is empty. That should just remove it. Text document, yeah. Version 23. Okay, new document text is all this crap. Types, and then here. So that seems to be correct. Like we should have received. Yeah, we should have updated our document in memory in LSP correctly there. So why is the diagnostic still here is the question. Did we send the diagnostics for that document? So let's go to server, flush diagnostics. Okay, we should have the version. Shouldn't the diagnostic include the version? Maybe. If we had diagnostic from before, we shouldn't have diagnostics from before, but maybe. Are we properly clearing the documents? We are clearing the diagnostics here. This deinitializes and we're clearing the diagnostics. So we shouldn't send any more diagnostics. But let's just in case, I will add a message here. Or okay, we already have a message here. So we didn't actually send any diagnostics, is what this is telling me. Right? Well, we did send this for version 22, but then this is version 23, and then we didn't actually send anything else here. So why is it still showing here? Why do we still have this diagnostic? I use stir tool for parsing integers, or stir to I, okay. This, or to long, I guess. This function returns long int, right? So I switch to stroll, or I guess you mean stir to ll, which is long int. Okay. Well, this is what's confusing. I don't like those types because it's better in Zig, where you see what type it is. Okay, there's one type that is like that, and that's usize. You don't actually know until you build. It depends on the OS and also the pointer's size. But, or it depends on the architecture. But yeah, everything else, you know that that's the length. In C, you don't know anything, basically. Well, you do, I guess you do know bytes and maybe shorts, I don't know. And what is a long int? Like, what is that? Does int even do anything? I thought long was int, like it was implicitly assigned integer, like just long. Can you have long something else? Like, what does it do to say long int? Or is that just to be super explicit? Or but yeah, that doesn't sound nice. Okay, so why do we have this? Long int is just a long, okay. And what is that? Is that doubling the size of a normal long? Like if long is 64, will that be a 128? Because int could be 32. Short 16. I don't envy that. Okay, so maybe there's like a message you have to like clear the diagnostics or something. I don't know. Or maybe, okay, maybe we actually have to send diagnostics for every document and just send an empty list, I guess. So we don't just go through, we have to go through each document. That seems so inefficient though. But I guess we could only send for the ones that has changed as well. Okay, so I'm thinking like this. Okay, so how it works right now is that we have a diagnostics array list for each document that we have in our memory in the LSP. And every loop in the server is like when we receive a message from the client and then we do something, we handle it. At the end of it, I can show you here, like in run. Here we read the message, we handle it, and then we also flush diagnostics. So what's this doing is basically checking all the documents and everything. If we have diagnostics to push, if we have, then we push, then we send them. But we probably don't want to clear the diagnostics at this point. We probably want to clear them here. Or wait. Or we don't clear them at all, actually. Maybe. Because the problem is that now we send them and then they exist. But then I'm just guessing. Okay, let's do a test, actually. Let's just do a test. So basically, I'm just gonna hack something here. So let's go to like the document. And then let's do like let's just should send diagnostics. Okay. And this we will say, or we don't need to defer it, we just set it to true. So every time we do this, which is basically when it gets like updated, I guess. Yeah, we mark this to be true, and then when we then flash diagnostics and we group the documents, we only include those that has this flag set to true. So if this is true, or if it's false, we continue. And then we should set it to false at this point. Okay, so that should only send for the documents that was actually updated. But then we also remove this this condition here that the length could be 0 and we could have no diagnostics. So I will remove that. However, now we don't have the URI. But we should have the URI should really be on the document itself. So why do we not have that is the question. I'm not sure. We have path. That should be the absolute path, I'm pretty sure. So we could just make the URI here. Let's just have a function here. Print or I'll print file path. All right. Oops. So now we should be able to get the URI from this. And that will be put in there. Now we need to clean that up as well. Because before we actually used the diagnostics to get it. Now we need to clean it up. So in the cleanup phase, where is that? Over here. We actually need hang on. We also need no. Wait. No, not this one. it's gonna be the groups, yeah. So actually we need like group iterator. No, this is entry value. And then free key. All right. Okay. Yes. Are we done now? What's this? Oh. That's the wrong thing. Okay. Okay, so now I think this should work. Let's build, and we'll go to this, and we'll start to make this function. There we go, and there we go. Hey, it works. Awesome. We got the LSP here now. Cool. And if we run some command that doesn't exist, well, this is also the issue. Like, you don't see the later errors because it aborts over here. That is one improvement that you can do. Like, treat this like you can see that, okay, there's a terminator here somewhere. So you would get like, yeah, maybe the new line as a terminator, because that's how this language works. And then we don't stop the parsing because this fails. We basically just, yeah, this is an error, but we keep going. And then basically just resetting back to wherever we was maybe before the line or something like that. And then here there's should be probably another error here. But then it should go through its merry way and still parse this stuff. And then get down here and also report an error down here. Maybe. Actually, it shouldn't report an error here because... well, I mean, technically we could probably build in some sort of detection of if this command exists or not. Maybe. But yeah. So if we have this, this is technically not an error because it could be a command called ASDF. But yeah. So we only get like parsing errors here, and lexer, like what they call semantic. No, lex. What's it called? Lex. Well, lexer errors. Something lexication. I don't know. Something, you know, something goes wrong with reading the actual tokens. Like if you have, I don't know, some kind of token that is, well, this is an unexpected token, but basically brackets are allowed, but maybe we have like some token that we don't actually allow. So this is like a lexical error, and then, and this is like a semantic or syntax error, where the token is correct, like we have this token, but it appears in the wrong spot. And then we say that every token that we could have gotten at this point will be these ones, but we got this one, which was unexpected. Okay, cool. So we got, I think this makes it so that we got like the whole pipeline, like basic function work here. Do you know why Zig doesn't have built-in interfaces? It has methods for struct like Golang, but so it shouldn't be a problem to add interfaces. You would have, I mean, yeah, I don't know. I haven't read like the org maps. There's probably guaranteed to be some kind of discussion about it somewhere in the Zig, you know, issues somewhere. But yeah, I don't know. It's you know, you could. The thing is with Zig is like, yeah, there's no built-in interfaces, but you could sort of build your own. Like there's a couple of different ways to do it yourself. Like one way is to use tagged unions, which is, I think, is preferred because then you actually can type it. It's not exactly an interface, but it's kind of. You can also like wrap other values into it maybe and use that, maybe what they call it, like decorator pattern, I don't know. But then you can also use like any type to be able to pass in anything, and as long as it adheres to the interface, then it works. However, the downside, if you compare it to other languages that actually has interfaces, is that you don't actually know which type you need to send in unless you know, because it doesn't say in the actual type. So there's no type constraint or information that says that it has to be this type, but it's still constrained like by the compiler because of the functions that it calls with the arguments that it calls and stuff. But it's still, you know, it's like, I think it's fine. It's like I've never reached a point where I'm like, F this entire language because it doesn't have interface. It's more like, yeah, I need to work around it. I need to work with the language and the things that it has in order to solve the problems. And that is not a showstopper for me. It's more, it's even better maybe because then, you know, you kind of get creative with different constructs you can do with the comp time stuff. So I think it's kind of fun that it doesn't have much built-in stuff when it comes to those kinds of like type constraints. But it does have, you can do any type of constraints now, because you can use comp time logic to constrain the type. The only downside is that, yeah, it's like it's impossible for like the LSP to know which type you're supposed to send in if you have an any type, for example, and stuff like that. So, but yeah. But yeah, or you would think of things in terms of not interfaces and just, you know, live without it as well. That's also an option. It would be cool. I mean, I would rather see that they extend the comp time system so that you can have better, you know, better like thing, like you can make even more, like because breaking down the interface construct from other languages is basically what we can do, and make something completely unique in Zig instead. And if they improve the comp time system so that the LSP can work better with it, then it would be really cool. That would be better than interfaces, because you could kind of make your own kind of interface and your own like language constructs that way. The only downside I see right now is that the LSP doesn't work very well with the comp time stuff. So, but hopefully that can be solved. We'll see. All right. Okay, can we actually run this? I think we can. I think we've already ran this here. Yeah. So this works. Yeah, so I guess what's left is just to try and, you know, make, for example, be able to make functions I get okay. One thing that's not part of the pipeline right now is type checking, but I think that type checking is such a extra thing that I probably don't want to have it, to be honest, right now, until maybe later. There's still like implicitly, like you still have this, we know that this is a bool, for example, we know that this is a string, so there is some kind of type system like behind the scenes that will automatically, like for example, like convert this to a string, for example. Like let's say you have a thing called b is true and we echo b. Yeah, you already saw that what it does, so it's gonna echo it to 1. So, and I did that because of I think, yeah, compatibility. Like it's probably better to have it like 1 or 0 instead of true and false. But yeah, so cool. Great. And this is pretty cool as well. You can you know, you can assign p to some kind of pipeline here that will become the like the process that is holding these. Now I haven't actually looked at the evaluator yet, or the script runner, to see what actually happens here. But I mean, what I'm assuming is happening is it's not a streaming thing. It's gonna take, that's what I'm assuming, but I don't know actually. It's gonna take the output of this, put it into the standard in here, hopefully. I mean, otherwise it wouldn't work, right? Or yeah, I don't know. It's gonna do that, and then we'll take the output of that, and then this will have the output and everything from the last pipeline stage that I guess succeeded or failed, maybe. That's also interesting. I wonder, like, if we put a fail here to see if what p is gonna be. Also, do we cancel this whole execution if this fails here? Like if we go down here, I think so actually. So if we just say, like I think if you do this, it will fail with saying like Jess is a bad, oh, unexpected token. Oh, I see. Yeah, I have to put it in a string. I probably want to have a special even make maybe an auto fix for this, like a special error message that's saying, hey, did you forget to put string around it, or like an auto fix. Maybe that's possible with the LSP actually. Hey Blue, how's it going? What's up? Okay, so it didn't fail. Wait, so that was actually a thing. Okay. Okay. I didn't know that. Okay, there we go. So now we get this grep error thing here. Okay, now let's we'll do this test to sh. Useless echo. Yeah, I know. Okay, we get all these errors. Wait, I'm not using value. Okay, well, whatever. So if we run this, do I have to do this or something? I don't know. I'm not. You can see how good I am at Bash. Like, I'm terrible. Let's just remove this. Hello. I'll just do like value there. Echo may not expand. Yeah, no. Okay. Okay, so it does do the same. It like shows, it prints this out, and okay. Cool. Instead of just an unexpected token, you could print unexpected token, try using quotes or something. Yeah, exactly. I was thinking like have a specialized message just for this kind of error here. And as I said, maybe even an autofix. So if you do this and then save, it will automatically format this string. But I don't know if you could do that with LSPs, like automatic format, or if you have to put that in the NeoVim config or something like that. But that could be something you could do. All right, cool. Yes. Now what? Do we want to tackle functions? Or what do we want to do? Yeah, here's the AST. Whoop. Why do we get this weird stuff? Oh yeah, that's the, okay, yeah, the colors, that's right. Print AST, no, runic. Yeah, that's the ASDF thing. Okay, anyway, what do we want to do now? So we did this. Was that LSP did change support document diagnostics? That is implemented. Cool. I mean, we have functions. What else do we have that doesn't work? So I have like test features. So like in here, there's a whole bunch of different stuff. So if you do this one, for example, this one has like import. Import doesn't work. Maybe import should be the next thing then. I think basically all of these has some kind of error in it. Yeah, because all of them use import. So maybe we should fix that first, because that is an error for everyone. So, okay. Imports. Now, actually, imports implies that we need struct types, because I'm gonna do the same thing in Zig. Is that every file is gonna be a struct type, and you're gonna have all the function declarations, all the public declarations. It's gonna be exposed to other like files that import this file, and yeah, so it's basically gonna be the same as Zig, to be honest. And because that's so easy, like once you have the struct type and you can treat the files as struct types, you automatically sort of have the module system. So you could just say, okay, I want to import this file. Okay, well now that's a module, that's a struct type, and now you have all these things on this struct available to you as some kind of alias in your the import there. So when you do like as we do here, this import, this will actually, this is like a built-in keyword thing here. So this would actually, then it would import this file, and I probably want to add like .rn here, because then you can also use the editor to jump around automatically. But you do this, and then this file will be read in and parsed and everything. You get the AST out, you get the struct type from that. So we construct a struct type from that AST, and then basically this expression here will become the struct type, and you can type .ensure to get the ensure function out of it. That's the idea, but it doesn't sound trivial to me. So it sounds, because what we need to do is, well, for one thing, we need to add this whole import infrastructure thing to actually read the file and everything, and we need to construct some kind of name for, yeah, we need some kind of we could have a cache for the documents that we've read in, the ASTs. I mean, we already have it in the LSP, so, but we could also have it in the parser, so we don't have to read the same file over and over again if it's imported by different places. And then also like the struct type needs to be constructed from the AST. So we need a function that takes an AST and produces a struct type. Can you call C functions in your programming language? I mean, you can call whatever executable you want. So technically, if you have a program that can call C functions, you can call that program that we call a C function. No, but there's not going to be any C integration. Like this programming language is not a generic programming language that is you're supposed to be creating like programs in. It's just a scripting language, like the Bash language, which is just for quick and dirty. That's the idea, like quick and dirty, like scripts that does some kind of workflow for you, like that. That's the idea. that you can easily run. It's just, the idea is just that it's gonna be, for me, it's easier to use than Bash. But and I just want to also point out that it's not a serious language right now. It's not really, the point of the language is not to be like, I'm not gonna release it or have any like serious thing with it like that. It's just a toy language for me right now. I mean, it could grow into something serious, but I don't think so. I think there's probably alternatives that are way better. But I'm just doing this for fun. Okay. I would try to create a game using your program. Good luck. You can program a game in another language and you can call it from this program language. Yeah, because the whole thing about, like, if you look at this, like, it's just a bash script basically. You know, you're just calling like echo. You're calling other programs with it. So you can't really do anything in it. You can't. The only thing you can do is call other programs and like manipulate the characters in here. But there's no. We're not gonna enable. You're not gonna be able to like do like arbitrary syscalls or anything like that. I would write such a function to call C functions using libffi and then call raylib functions using it. Alright, yeah. You could do that. I mean, technically, you would be able to have a loop. And you could have a game loop, I guess. But I guess, I don't know, it would be so inefficient, that's the thing. I would applaud you if you try to do it. Or if you succeed. What do you mean by making a language? So yeah, I'm basically I'm making a program that can read source code, parse the source code, and then execute like this. Okay, a language, this is a scripting language to be specific, but so the point is that you would run the code immediately. You wouldn't compile it to an executable that you can then run. You would just run the code with the program. So for example, this program on the left side here is in my language here, and then you can just call this echo is another executable that you run here. That prints this out. And so we have this Runic. Runic is the name of the language. We have this program that reads in this source file. So I will run this file and it will execute the stuff in it. Are you a developer? Chet Ananad? Yeah, let's see. I want to do. Let's remove this, and I will just say like echo. Oh, we got a crash in the LSP. Index out of bounds. 2, 1. Yes, it's on GitHub. However, I haven't pushed the latest changes yet. Also, right now it's marked as private. I'm gonna make it public soon. I'll do it. I'll do it today, probably. Index out of bounds. Line 0, character 0. So that should just insert this at the start. We get a panic index out of bounds. Do we see where? Is it here? So it's in the, when we try to parse it, I guess. Wait, so that should happen. Okay, so if we have this, we restart or stop, start. No? Okay, that's weird. So we have, okay, let's go back actually. So I deleted that, then pressed E, and now it fails. Yeah, that's why I can't find it. So what if we start here and then just press E? That's not the same. Okay. It's consistent if we go through those steps. That's interesting. But not otherwise. And here it says like the new text. Yeah, new document text is... Why do we have like 2 new lines and an E? And then a new line. That doesn't look correct. Or is that that's just a log here. So E should be there, and then we get index out of bounds index 2 for some reason. What about here? This is now empty. Configuration. Right. Yeah, that's the text we get first. And that's like did open. Okay. Let's check what actually did open does. So we open the document. We don't actually need to open, well, we don't need to read the file because we get the text here. Yeah, so we don't read the file here. We just initialize it here. What do you actually do? You just duplicate it. Okay. And then yeah. But then we also have this update here, which is called from did change. So there could be something wrong here, probably. So hard to look at these logs here. But yeah, the changes, it's just one change, right? Yeah. And it's strange as well, because this says the new text is E. So why would we get out of bounds? Oh, we're only saying it here. Oh, I see. Let's say it here. At this point we should have the new text. We're freeing it here, but it's duplicated here anyway, so that shouldn't be an issue. And then you will look at the document text to parse it, so that should be fine. Okay. Still got an error. I mean, of course, we didn't actually do much. We just changed where we post the thing. New document text is E. Still trying to access this index here for some reason. Let's go and see what this is doing here. So Lexer 148. Right, we're calling next, of course. Okay, hang on. Parser list. Okay. Parser is using contents, which reads the file. Wait. This is just the index. No. Here we go. Here it is. Parse file, parser self text. And this is called here, and also after this is done. So the text should be updated at this point. So I don't know what's happening. Trying to think. Like first we have it. Like why is there a difference? Like first it's like this. We delete it. We insert an E. Okay. We have to do this first, I guess. And then now it crashed. So let's go here. Let's go to parser. Let's go to Elixir. Let's enable. I guess we can do it from here. Parser. Logging enable true. Parser stream. Elixir logging enable true. How much time do it take to compile your interpreter, and how much lines of code your interpreter have? I don't know. It doesn't take long to compile. You can see here. Although, okay, that was a fair comparison. Like it has increment. I think this has on Linux at least. It has like incremental. I think builds. If I remove these, yeah, it takes about the same time. Although I would say this is probably not fair as well, because when I save, it actually also compiles. So let's do. I mean, okay, let's see if we go to main. Yeah, this is not fair at all. We'll go to main and we'll say I'll just append a something like this onto where is this? Okay, and then now we build. What the hell? Yeah, I don't know. It's hard to tell because I think it's, but it is pretty fast. I would say. Like they have recently, like in the last version or previous couple of versions, they have been replacing the backend, the LLVM backend, for their own compiler, which is much faster. what if we do here? Okay, 1 second. But I think it is I'm not sure if it's incremental though. Yeah, but now it's okay. Yeah, so if it's incremental, then yeah, it's like caching already built stuff, and it kind of tries to calculate what it needs to rebuild. And so the first pass might be like, let's say we do this. Actually, let's just remove. I can't remove the cache because the cache, I'll just remove zig out maybe. Well, because the cache includes like imports. Well, do I even have any actually imports here? I don't think so. No, I don't have dependencies, so I should be able to just remove the cache. And then also zig out. And now we can do. So it takes a fair bit amount of time, 3 seconds. Or 5.57, 6 seconds, yeah. All from scratch. So that, I guess that proves that it does do incremental. So this is from already cached, then 1.3, yeah, in this case. Yeah, it seems to be a bit of a setup time there. I'm not sure. Like, yeah, that code that I just added was, it doesn't even, it's not even included, but it still takes 1 second, over 1 second to do the compilation. All right. How to make this work? Okay, so now that should be okay. So now we should have this being logged. So I will do this and then this. We get the error. Yeah, here's the error. So parser, parse script, parse statement, Lexer next, 011, skipping white space, Lexer, next token is an identifier. Well, that seems correct. We can't really see what it is from here, but yeah, and then it tries to read like a pipeline stage. Line 1, column 1 still. We're trying to read the next one. But now we're at the end. So we get... Yeah, so it does work. We get the next token is a new line. And that's the end. That's the end of file. And then for some reason we fail here. I don't know why. It tries to run next. Consume statement terminator. The error log, what is this error log? It's the LSP error log in NeoVim. It's horrible to look at. Yeah. So the thing is, like, here's like you can see here that it is calling synthesize trailing new line. So basically that means we've reached the end of file, or yeah, the end of the string, and then it like inserts, it like makes a new line because that's the terminating thing. But this is like skipping white space. That shouldn't skip new lines, yeah. And that is at 1-1 still. Wait, 1-1-2. Oh, index 2, I think, yeah. No. How does that work? Index 1, line 1, column 2. That's right. And then, yeah, so we get the synthesize, and now the lexer is at the next line, which, why is column still 2? That's weird. Also, if we go to like did open, that doesn't report the document. It does report this though. Okay, here we never get to the synthesize thing. This is did open, yes. Index 0, 1. Index 1. Index 0, 1, 1. Next. Identifier. Next. Skipping white space, new line. Next token, new line. But there's no synthesize at this point, so that's weird. Is that the issue? Like, but there is no new line here though. There's no new line. Like when I open this, next token, new line. Skipping white space. Okay, so okay, and the problem is now we do this, we get an empty whatever, we do this, it should fail. No, what the hell? Okay, now it should fail. We delete, insert 1, and it fails. So I think the problem is here that when we get to the synthesize, and then we try to do next again for some reason, then it goes out of bounds. So we parse the expression. This parses the pipeline and the stages, and we're parsing a bunch of arguments. Here we have consumed the next. No, we don't. We just peek. If we encounter a new line, we don't consume it. We just return, so we shouldn't have consumed the token. We just peek. Then we peek here. If it's a pipe, we consume and do another stage. If it's anything else, or if it's this, we do this. If, yeah. But we, crucially, we haven't consumed it yet. Okay. Then we'll go back here. And that just does that. Yeah, so we're not consuming the terminator. Okay. And I would try to consume it. However, at this point, we have peaked at the end of file, or yeah, which synthesized into a new line. So at this point we should get the new line, and then we consume it. That should work though, and then we just return and we're done. Where's the error happening? Skipping white space. Where's the parser at? Parser, yeah, 465. Wait. Oh. Parse and skip lines. Because what I'm looking for is basically an edge case where you would be at the end and we might consume one too much things. That made sense. So we're running the parser there. Man, it's so hard to see where the error is. Parser. Okay, 532. Right, this is the parser that we're using, and we're doing that. Oh. Yeah, so it does next. But that should just return an end of file now. So that's why I'm confused. It shouldn't. Alright, we have a bunch of C coders in here. Zig is better. Okay, maybe I should, like, sometime I should try C, like do a small project in C, and then I can do like a comparison. Yeah. I think you would have to have more experience than just one project, but to be able to make it like a meaningful comparison, but Zig is better. Okay, so let's see. Actually, I should start saying let's Zig, and not let's see, because we're not seeing here. Okay, is it here? Wait, where is the actual error actually? 148. No, it is here. If we're at the end, which means what? That we're past the source length. Yes. So we're still failing. If we're at the end, we're synthesizing. Otherwise, yeah, this doesn't make sense. Why the hell are we doing this? This should just be like an... Is it just no, why we should be able to do this. Because the length is 0. Well, yeah. So even if someone tried to deallocate this, it shouldn't, the allocator should see the length is 0 and it should abort. Oh my god, yes. No! Wait, we have another issue. Remove this, add it back, remove, then it fails. What the hell? Oh, this is such a... now we're approaching the case where this is such an edge case that it's probably not worth fixing. Okay, where is this happening? Server, what? Server 701? Oops. Haha! It works! Okay, okay. Oof, that was close. I was close to, yeah, started to bang my head against the wall or something. Anyway, so, great. Let's... do that. So, let's just do like let lib thing equals true. So we just have something in here. Okay, and then, whoops. And then you would say let lib equals import lib dot runic there. Yes. And we get unexpected token, and I'm not even sure if I want to have this syntax. Like I've been thinking about like function calls, like should they really, like, since we're kind of treating executables as functions here, maybe we should also, like, this should be consistent, like this syntax should be the consistent syntax. Like you have a function name or an identifier, you pass arguments to it, that is the argument to the function. So if you have a function called import, let's say, we should do this and not have the parentheses. Even though import is kind of like, it's a language construct, so it's a little bit special, but also it's easier to, I mean, if we have this, it's easier to do this, for example. Otherwise you would have to do like this, I guess. I mean, I guess it's fine. I don't know. There is something that could be changed. Okay, one thing that I actually do want to do though is I want to change all the lets into const, actually. Oops. So I'm gonna do that. Right. What the hell is this? Okay, whatever. Oh yeah, that's right. Because it's supposed to be more like zig. I don't know why I chose let to start with. Let and mute. It just doesn't make sense. Const and vars is better. Now it's just because it's supposed to be like zig, the zig syntax, so it makes sense to have consistent syntax between the languages and not have different, like all of a sudden we have like different syntax when it comes to one part but not the other. Like the only thing that changes now syntax wise is like how you call functions and you know, the built-in bash stuff. Okay, now let's do the same for mutable. So that's gonna be like var. Or mute. Okay, so now we should have like some kind of thing here. I don't know what this is. This is probably not used. Let's change it anyway. Node types, JSON, sure. Let's change you to var. And var. Const Why do we have two? Okay, whatever. All right. I don't think these are used. I'm just gonna change them. All right. Wait. Do I need to like recompile or something? I think it was 14 I need to have. Also, it's not grammar JSON, it's grammar JS. Why is this not working? Oh, probably because of this. There we go. Okay. 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 Unexpected token string start, expected that, right? Because we already have like a kind of a rudimentary import thing. I'm gonna change it though to use this kind of syntax. Let's do that. Maybe, I don't know, import is such a special case though. It's such a special, maybe it makes sense for import to have that. Although I don't like moving from the convention though. Man. Also, it would be cool, like if you make a function, like let's say you get this. This is the result, like the result type of the function, but in bash or in like processes, you have like there's like multiple things. You have like standard out, you have standard in, standard error, you have the exit code. And so basically I'm trying to like, I want to encapsulate all of those things in this function. Like these functions should work like those kind of like executables. So what I'm thinking is maybe we could type the standard in and saying that this is, I'm just throwing out ideas. Like maybe we could support like a type here. Like let's say you want to take in or either here, like this would be the standard in spot, which would be, I don't know, a number or something, or integer, I don't know. Actually, these are like this. Okay, so standard in expects an int, and then void out. And then you can take like arguments to say like, maybe this is like format int, and then you get like radix or something like that. I don't know. And but then you can't really bind this though. That's the maybe you bind it like this. I don't know. It's such a special thing because yeah, the normal like function signature. It's gonna be interesting to see how you could maybe change it. I mean, you could also say standard in here int, but then it's just like a normal, you know, input. You could maybe add, I don't know, some kind of special syntax like at standard in, and that will make it so that yeah, now we can get the standard in, and then you can actually use that later if you echo. I mean, let's say we have a function that is like parse int standard in is a string, and then we get an int out, like a maybe int or something, I don't know. But let's say you just get an int out or an errorable int or something like that, and then that does something here. And then this one would take that int and do something else with that. Okay, and then you can echo like 15. You can pipe that parse int with no parameters because it doesn't need any, and then we can format that with like radix, I don't know, 15 or something, or I don't know, 16. So so something like this maybe, because then the functions will sort of work exactly as the executables, except the executables are basically the only thing they work with are strings. Like you put string into standard in and you get string out, and all the inputs are strings, like all the parameters are strings, and then these functions are the only. It's basically like typed executables, maybe, like you could say. So then this would exist in this scripting language only, like these like type checks for the standard in and stuff like that. And it's not even standard in, like we probably wouldn't make a process that does this. We would just, I mean, since we're working with Zig as well, like the way it's going to be stored in memory is probably, if it's an int, we're passing an int standard into this function for standard in. It's basically just calling this as a function with this as an argument here. But then it would kind of look like processes talking to each other here. Something like that. I don't know. So that's kind of what I'm thinking here. And I'm also what I'm thinking about the import. Yeah, let's start with this syntax, and we could change it later, I guess. I'm just gonna BRB 1 second here. I'll be right back, and we'll start working on the import here. All right. Let's see. Okay, so something like this, perhaps. All right. So okay. Right. So let's go and we'll start at looking. Okay, let's start looking at the tokens. I'll just simplify this a bit. Let's do like test R instead. I'll delete this. And we'll just have let lib equals const this print tokens test.runic. All right, so we have all the tokens. The tokens work. We have the keyword import. The thing that doesn't work is making an AST here. This does not work. So we have the parse import expression. So let's go ahead and look at that. Wait, parser, here we go. Parse import expression. Yes, good. It's an expression, of course. It's part of the expression types. It could really be. It should probably be at the top here, to be honest. Yeah, because we want to consume then this and then the next. And if you want to do more things after that, then this is going to be considered an like you can have this and then dot lib thing. That's going to be possible because then this will be consumed as an import expression, and then you can like do stuff after that. So that actually could work, hopefully. So because yeah, import is a keyword, so if you're using that, then that should be fine. Yeah. So let's see, we're expecting an import tag. We don't expect parentheses now. I guess they could be like optional. No. Well, we're parsing a string literal without interp, right? Because for now, I think I don't want to support imports that have like dynamic imports. Because then it would be really hard to like analyze the types later. It's probably like technically maybe possible if the values are comp time known. But yeah, that's gonna be a whole other can of worms. Or you would mark the module as the type as kind of highly dynamic or something like that, and then everything you use is gonna be all, you know, unknown types. Which right now we don't really have a type checker anyway, so it's gonna be very important, very interesting to do a type checker because I've never actually done that. That would be really cool, actually. Maybe I want to get to this today. Like just implement a super basic, like just a start of it. Okay, but let's make the import work here first. So let's see, alloc expression. Right, so we're parsing a string without literal interpolation. I'm not gonna actually, you know what? This doesn't work. Yeah, I can just see that this does not work. We actually want to parse a string literal, and then we just want to make sure that there are no interpolations in there. So actually we don't do this. We do a string literal. And we will just ensure here that there are no segments that has that are of the type interpolation. So if segment is equal to interpolation, then we need to return some kind of error. Which we probably don't have. So string interp not allowed. Otherwise we just return string literal. Yeah, I guess we need to concatenate it. Or we could just return the string literal right here. Ah, what the hell, let's just concatenate it. Wait, what's the best way to do this? Like there's concat here, but that takes a slice of... Let's just make a result be an array list of like just a string. We could pre-calculate the capacity and stuff, but whatever. And then at the end we'd return this to on slice. Alright, and then we will do... Actually, is there a version of this, like to on slice? Like, I still don't understand why this can't throw. I always go in here and check. What's happening here? We take the old map, we'll remap it for some reason. We take the new memory, or we do new memory. I mean, I understand that you probably don't want to use the same pointer, like, but couldn't you just set the capacity to 0 here, and then set your own pointer to undefined or something like that, and that would make it so that next time you want to allocate something with this list, you would need to allocate more memory. You would need to allocate new memory. I don't know. Anyway. Maybe it's some kind of optimization or something. I don't know. Anyway. Then we go through the segments again. Actually, we could just do it here. We could do it here and then defer the initialize. And if we're here, then that means the segment is a text. So we could do result append slice allocator segment text payload, and I don't think we need to deinitialize this because this is initialized using the arena of the whole parser, so that should be fine. Actually, then we should use the arena here as well. No, we shouldn't. We shouldn't, because we're doing this to own slice. Actually, don't we have something like copy to arena? Yeah. And then we just defer the initialize. There we go. There we go. All right. Okay, so that should be fine. What's happening here? Oh. Okay. N should be at modules. Wait. Module name. No, we should get a span. Yeah, let's do like span. That error there. Okay, what's this? Expect type found this. Oh yeah, so this is the payload. There we go. Cool. Yeah, and that should be in. So now this should be in the arena, and the span is just the span. Okay, cool. So now we should. Now that should work. Here, there we go. We got an import into there. Okay, so we made the parser kind of work with the import. Like we get an import statement, but we don't actually read in this and import that also. This parser is only for one file. I mean, I guess that's fine. I guess that's what we actually want to have. Standard array list U8 reminds me of macro DA type that I need to have dynamic arrays for any types in C. But in C I have to use macros. I don't know how array list works in C under the hood. Okay, I can show you. I can show you because it's not that complicated, to be honest. Yeah, so basically you have the standard library here. We can go to array list here. So in Zig, instead of macros, you would have comp time stuff. So here's a comp time function. It runs in comp time to produce a type. And so this array list is a function, and it takes another type here as a parameter, and the result type is a type. And then we have a module called array list, and we call another comp time function which is aligned. So now we have like an aligned array list. But in the end, all it is this return resulting in a struct type here. And of course in Zig you can have functions on struct types that are called like member functions. You can also have static functions as well, but they are not really that special. They're just functions that happen to be kind of namespaced in the struct. But anyway, so a struct, yeah, can have fields just as a normal struct in C. And you can also have like declarations, like, you know, this is like a comp time constant here. which you can use to initialize a new array list. It's basically here, it's basically saying that, yeah, this is the empty array list. Self is just the type that you're currently in here. And so this is all the only fields. Like you have items, which is just a pointer with a length, as it's a slice. A slice is just a pointer with a length attached. It's in Zig, you type it like this, but really all it has, it's like a struct with two fields, pointer and length, and also the type is embedded in it as well. That's what a slice is. And then you also have capacity, which is how much has been allocated on this pointer. So this pointer will always point to the actual appended sort of items that you have. So if you start out empty, it will have no items. If you append one item, it will have one item. But as soon as you append one item and the capacity is 0, then it's gonna allocate memory to be able to store the items. So, and that's basically it. And then there's just a bunch of convenience functions. You have like init capacity, where you can set the capacity from the start to be whatever you want, so that you know, for example, if you're never gonna get over 100 items or something like that, then you can init the capacity. So then it won't have to do a bunch of allocations later. You just do like one allocation here and that's it. Yeah, there's just a whole bunch, and then you call deinitialize to free the allocated slice here. And yeah, and that's it basically. And then there's a whole bunch of convenience functions here. And so yeah, in order to work with generic types, you would use something like this. For example, this is one way of doing it. And you get like compiler support and everything for that. Comp time stuff is like its whole own chapter in Zig, and you would have to spend some time to actually get to grips with it if you want to be able to do stuff yourself. That's a little bit more tricky, but for me it took a while to actually get used to it. But it can be very useful and automate a lot of stuff. Especially if you want to let's say you want to loop through all the fields of a struct. You can do that with comp time, for example. That's just one cool thing about it. You can do a whole bunch of stuff. And you can do like introspection, like typing introspections and stuff like that as well. All right, let's see. Yeah, okay, so now we have this import expression, right? We have it in the AST, but we don't have the supporting structure around to actually parse the imported file and all that, and construct the kind of the struct type as well. We don't really have this here. We need struct types. We also need to parse imported file, put it in some sort of AST cache or something. And where would this happen? This would probably want to be happening in both the LSP and when running the script, because you want to parse imported files for errors, presumably, and get like, you know, the type and be able to like autocomplete and stuff on that. So yeah, how would we go about this? I mean, we would have to have something that could describe a struct, and yeah, have the things that we need to be able to support there. So that would probably be some kind of AST thing. Do we have a struct here? No? We have enums, apparently. Unions, apparently. Import statements with this. I mean, this doesn't make sense, like the alias. We don't really have an alias for the import. How does that make sense? Yeah, we don't even have... Oh, I see. That's a different thing. Yeah, we don't actually have import statements. So I should probably just remove this. All right. I'm gonna do this. Yeah, of course you are complaining as well. Okay. We have this import expression. So where do we have like types? There should be like a type expression. Oh, we do have type expression. Okay. Cool. So we have like identifier, we have optionals, promise, error unions, arrays, records, tuples. Not sure. Well, I guess record would be like the closest type, I guess. Function. Yeah, I guess record is like the thing that it used to be. It's not really like a... yeah, so what we want to do is we probably... Here is what we wanna make this a struct instead. There's not gonna be records per se. There's gonna be structs, and then this is gonna be a struct field. We could probably use like what I was saying like another time was that there is a zig module in the standard library, and there's like an AST here, and here you could maybe use this to... You could, like, if you're doing like a language that has kind of the same structure as the Zig programming language, you can just use the Zig AST if you're using Zig to program it. And I mean, since I'm kind of using Zig, I'm using Zig to make a Zig-like language, at least in the syntax. Maybe this could be a good way to do it, but I don't. There's gonna be. I think there's probably gonna be enough differences that this might not be like a good thing. Also, it's using like other weird things here. Like I don't know what this is. What is this AST here? But if you could look at this, like we have L brace. What does that mean? Fields. Yeah, because you could probably look at this and try to do something with this. Abstract syntax tree for SIG source code. For SIG syntax, the node is nodes. Serial contains a list of subnodes. So, right. So you could probably like use this like if you're using zig-like syntax, you could just read in a zig or you know the file with this. And then do something with AST. And that's pretty cool. Yeah, I think that's just so cool that it's like part of the standard library. And it's just available. But yeah. I'm just gonna do this here. It's also interesting, it's like, okay, I'm just gonna look at this. It gives you a struct in it. We have, but it only has fields. I guess L brace might be like where it starts or something. I don't know. I have no idea what this is. L brace. Node main token. Node. Token index. Okay. So we have like components. It only has fields. It doesn't have like declarations or functions or anything. And here's like the type expression, I guess. Optional index. So it's just an index into the type expression. This thing, it's just a node. Yeah, this is super like, I don't know. It's a bit abstracted and optimized here, so I don't know. Anyway, I just thought that was interesting. But we are not going to do it like that. We're gonna just make it very naive and simple here. So, alright. So we have fields. We should also have like functions, like declarations. Public declarations, basically. I'm not sure if I'm gonna add the public keyword. Maybe. We'll see. But for now, I'm just gonna say declarations, maybe. So we're gonna have like fields and declarations. And the declaration has a type. It has a span, it has an identifier. I guess it's kind of the same as a field. But I guess, yeah, the difference is we don't really have fields right now in the files, though. You can't really, we only have like declarations. You can't define a field on a file struct right now. So maybe there's only declarations then. No, but we're supposed to be able to support structs. And then you need fields. Because otherwise it's just a collection of functions. But I guess we could start there. We could start at only... I mean, we could still have fields here. And then just... If we don't have a way of defining the fields, it's just going to be empty. And for file structs, then it's always going to be empty, I guess. Okay, anyway, so now we have like the declaration. Now we have like a way to actually store it, I guess. yeah, so great. Now we need to the thing is, like before, the import happened at the execution step, but now we want to have we want to, as part of the like parsing a file, we also want to handle all the imports. If we go, let's say we go back, we go to the beginning, we go to runic main. This is the entry point of the execution of like the interpreter, right? And then we have this dispatch function which will actually like run stuff. And so we have like script, run the script. And before we run the script, we have to compile it, or not compile, but parse it. And so we're doing that somewhere. Over here somewhere. Well, actually over here, yeah. So we're parsing the script. Now, part of this should be parsing the imports as well. Right? So what I'm thinking is probably part of the parser then is we're gonna have like this source is this is very specific to just one file right now. So I want to make it be able to parse multiple files. So maybe we'll have like documents. Like this is akin to how the LSP works. Except the document store is very specific to LSP right now. But basically we have a string hash map of documents. We can open the document, it will parse it, it will do stuff there. We have like we have support for updating the documents, which doesn't make sense for the interpreter. The interpreter is just gonna run it. But we want something akin to this. Basically, just being able to store the document. It's just gonna be I mean, basically this probably, I can make it very simple here. Let's I'll just make the document store here, I guess. Import it. All right. So we will have the documents, or I guess we can call this just a map. So we have a string array hash map. I like using array hash maps because then you can just loop through the thing. And then this would be, I guess, some kind of document type. I'm not sure exactly what would be in here. Probably the source and maybe also the AST. So AST, and it could be populated or not, maybe. Or it's always there. We'll see. I'm not sure. Actually, I mean, it's true that this is a bunch of statements. It's also true that this is kind of like, this is where it gets weird, actually. Okay, I just realized something. So in in zig, if we just have like a zig file here, in zig, the top level is a struct. Let me open up lib here. Let's say we have like a pub function, hello, whatever. So let's say we have this function here, or there. Okay, now if we import this file, the idea is that you would be able to access hello from the one that imported it, and maybe also even these. And maybe we'll add like a pub keyword that will make you can explicitly export things. But the thing about runic files is that you can also execute some arbitrary commands as well, right? So what will happen if we import this file? Should we allow execution of these statements here? Or, as in the case of a zig file, like if you have, this would be akin to having this, and then pub const this, and then here it will be something like, you know, standard standard log or debug print hello. Yeah. However, this doesn't work because you can't have statements like this in the struct type. It's the same as having like saying like you have like a some kind of my struct here, and then in the struct definition you would have some kind of executed statement. That doesn't work. Yeah, it doesn't even parse correctly here because it's like expecting, it doesn't expect this statement here. You have to put this in a function and now all of a sudden it works, except it doesn't work here, but yeah, whatever. If I remove this, it works. So now there's no issues because it's in a function, and then you have to run the function in order for this to execute. But you can't just have statements out here unless it's like a comtime statement. That works, but you cannot have like runtime statements out here. You have to have it in a function. So the context has to be a function, but the context here is like defining a struct type. So what does this mean? Like having this echo here. What would this mean? Like I'm thinking like maybe you can import lib or lib like this. So, and then you like call it. You call it and then it executes the things. Maybe. And if you just import it like this, it won't execute the things, but it would like have the type here. Or that could be one solution, maybe, I don't know. It feels a little bit iffy. Or we force everything, like every like executable statement, to be in functions. But that doesn't feel right either, because that kind of removes the ease of use of the language. So yeah. How does it work actually in Python? Because I believe Python you don't need a function context. You can just, like, running the Python file will execute it as kind of like a function, and then importing something. What happens when you import something in Python? Yeah, this just does this. So let's just do print hello. Hello. Okay, and then we have like lib print hello from lib. And then here, how do you import actually? Import lib. Oh, it just executed. Okay. I mean, I guess it's fine. I guess it's fine. It's like, because the purpose of the language, or the purpose of the lib, you would build into the library file itself. Like, if the purpose is to print something or execute some stuff, then it should do it. But I'm just thinking, like, it also feels kind of strange that it would execute a bunch of code. Why not just an empty scope? Add all empty scopes to an array that gets run at the start, similar to JS on load, would even make them async. Empty scope. Add all empty scopes to an array that gets run. Right, I think what's gonna happen here is basically, if we have it in this order, it's probably just gonna do if it's like this, right? It's gonna evaluate from top to bottom. So we have a function here. This is this. There could be dependencies as well. There could be like, you know, you would call hello and get some, you know, and now this actually depends on this. So if this is defined before this or something like that, that could be an error. But we actually have the AST for this, so we don't really have that dependency, unless this depends on something else, I guess. That would be interesting later when we have like actual functions with closures and stuff. We'll see though. But so here is but you could do there. So you could build like a dependency tree, and then have things out of order. Maybe, I don't know. Maybe that's a continuity issue there. But anyway. So then hello would execute, and you know, logically, if you import this here, then you would want this to execute here and not like before, like this. So we would just go through all the statements probably and just execute them one by one, and then this gets executed. We basically import lib, execute everything that's in there. However, we're also kind of treating this as kind of like a process that gets, yeah, that could be it. Like we just treat this as a process, same as this, because you can also do this, right? So you could do this, which doesn't actually echo this. Now that's stored in this, it doesn't echo to the standard out of this process, that the whole process here. It will just store it in E here. So if we do like, let's say we do, I'm gonna remove all this. So let's have like 1 is echo, or let's do 1, 2 will be echo 2, and then 3, and then I will add the output of 2 there. So this should echo, the result should be 1, and then 3, 2. Let's name this echo 2, just so we don't, just so it's clear that this is like, actually if we name this 3, maybe it's more clear if we do this 2, 3, yeah, maybe it's more clear if we do this, because then the order will be correct here. 1, 2, 3. Right? This is the expected input, right? 1, and then we echo 3, but this doesn't actually echo out to standard out because we're storing it here. And then we echo 2, and then we're interpolating the result of this into here, right? So if we run this now, yeah, we get the expected result here. 1, 2, 3. And for some reason we get like a new line here, which I don't understand. But anyway, that's like a bug. So that is the thing. So if you say const lib equals import lib, right? Now this is like it's importing itself, but but yeah. So this should like execute this, but the output should be put in here, really. So it's kinda the same as, I mean, okay, you could do it in different ways actually. If we import here, the result is gonna be, what I was thinking is gonna be the struct type that represents this file. However, it could also be ran, so you could have like run lib equals to runic lib rn. So that would actually run, you know, it would run this file, and you would get like the process output here. And I feel like this should be different. This should be like just a struct type that you get from importing this. It shouldn't run the file. We should just like get the struct type that it is. That's kind of what I wanted to have. So it's like if we echo run lib, this should now be hello from lib, right? But if we echo like lib, that should be some kind of string representation of the struct type of lib. So this should be like an empty struct, and maybe it also even has a name. So this would be like a struct, and then the name here, which would be like I don't know, at for root or something, I don't know, or just the whole file name, you know, just to have a unique identifier here, and then like lib.rm, something like this, right? However, it's like, okay, what actually happens when you import? That is the question then. Because you could have statements in here. You could have like a function, hello, you know, and then you have another function here. So you might have like greeting, name is lib. You could have a greeting here, and here in here you do like hello or greetings from name, right? I mean, you would kind of know from the ST that this, because this is like comp time known. But what if you do echo lib like this, right? So now name is like the process, and it would result in the same in the end. But now this relies on the execution of this command. I mean, okay, technically, we could probably do something like this. Like, we could probably import this without executing anything. Then when we call this function, we could execute, we could see that, okay, this is like depending on this, which depends on this. And then we execute this to get the result here that we can use here, and then execute this. Maybe something like that. I don't know. That seems very complicated. I don't know. Because I've been thinking about having kind of like a lazy dependency based system anyway. But it, I don't know. Also, like, yeah, so the because and it also may play into all the whole like streaming thing, like if you have a pipe, you know, like this, and this represents like standard in, so it would take standard in. But let's say you have like, I don't know, tail f and then a log file, you know, and then do something, pipe it into, I don't know, echo or I don't know, just to pipe it into something, you know, that would just log it out. But this would be a streaming type thing, so they will get stuck here and pass it into cat. But you could also make this like async like this, and then and this would run in the background. But the point is that this, like, it is a streaming thing, so not, you don't wait for this to complete and then run the next pipe. It's gonna be, the whole pipeline will run in a streaming manner. So, and the reason why I'm talking about that is basically because this whole thing kind of, it feels like it plays into this a little bit. Like if we have like a dependency map somehow, like you call greeting, like when you import this, nothing gets executed, but you call greeting. Now greeting depends on name depends on this, so you just execute this to get the result name, and it might not even be, you know, it might not even like, let's say this is tail f. Let's say we have another function, tail log or something, and this would echo yeah, some kind of log thing, and then it would just echo, no, it would do this, it would just tail this here. So now this function will, like, it will block, and it will continue to echo stuff out to the standard out, right? So if you then you import this function, nothing gets executed from the start, but then you call this function, it will execute this, and then will execute this. It doesn't actually depend on anything else though in this case, so we don't need to execute anything else basically. But that's what I'm thinking. Maybe we can do something like that. I'm not sure what the repercussions of that would be though. It's like it could end up in a mess. I'm not sure. Or in some kind of weird, like, you don't really know what's gonna happen when you import this, so you don't really know, you know. Another issue is that, let's say we call this already, and this would be now, let's say we have something that is time dependent, so you would have like the time is some kind of I don't know, if there's, let's say there's an executable that says what the date is. Now, when is this executed? Like, should this be executed right away to get this? Because you could have like get time, and let's say we just use standard out, so we're just echoing out the time. Now it's gonna get executed when you call this, so when you call this you get the time right away, or I mean you get the time when you call this. You can't time, you call date, that's when you get the time, right? But let's say you have another, let's say another script calls get time again. Now let's say we already executed time. If we cache this or memorize this, that's gonna get the old time and not the new time. I guess that's what happens when you call this, but it's also not gonna get the time from when you actually imported the library. See what the problem is there. So I don't know. I mean, the easiest is just to execute everything, and then you get you know, all these declarations would be done. They would, you know, have their values set right away. And when you call get time, it's actually just gonna refer to when you imported the file and not when you. Yeah, I think that makes sense. You import it, it's just gonna execute everything, and you're gonna get all these declarations and name. You will be able to kind of access the things on this struct here. That does make sense. That does mean though, however, that when we're defining a struct, we should also enable arbitrary like commands to be run. Or at least when we're executing it. Like, we could build the AST, but yeah, when you're actually executing, we should execute it right away and produce the type. But the type should be available though. The type shouldn't depend on the execution here. No, it doesn't depend on execution. We know the type. Yeah. So when you do this, we should probably execute it right away. Just so that everything is gonna have the correct values. Yeah, I think so. Okay. During execution, when importing a file, it should be immediately executed. Now, what about the results, though? I guess it would just use the standard out. Like if you have things like echoes and stuff in here, it's just gonna be to standard out. So when you import something, it's not gonna be put in some result or anything. It's just gonna be put to standard out. Yeah, that's just what's gonna happen. Is there a thing called date, by the way? Yes, there is. Okay, cool. Okay. Cool. Why don't I get errors here anymore? Is the LSP not working? Maybe it gave up. Okay. Anyway, yeah. I think that's what we have to do. Okay, so how do we now go ahead here? Let's see. Oh, so we do actually parse it now properly. No, that's test. This should fail. Yes, we do get. Yeah, why don't we get this when we? Do we have to do like restart? What is happening? I don't understand. It's still stuck at the same... No, this is old. This is like super old. What is happening? Is the LSP stopped? Has the LSP stopped working? Oh, maybe because of this. No, but it should still have the executable ready. Did I delete this or something? No? I don't know. All right. Anyway, let's continue here. So yeah, the document store. Okay. So the whole thing here, I was trying to read. Or I was thinking like, okay, well, what is a script? What is a struct? Actually, the struct only defines the type. The script defines a bunch of statements. Now that is what the file actually is. But then we should be able to get a struct from a script. Yeah. Wait, where's... We should be able to get a struct from a script. Where would that be though? Should we put it here? From script. We could just put it here, I guess. I would have like fields. Actually, this could be a hash map with identifier as a name, because then we could easily check if we have conflicts. Maybe we don't actually put it here then. Maybe we put it in like the parser or something. Yeah, I'll just put it over here. Struct from script. Where is the struct type? Oh, it's a type expression. All right. And this would be string array hash map. So this would be like struct field. Wait, empty. I think this one actually needs allocator file. All right, and then we need declarations. And then we just go through each statement of the script, and we just add, we register all the functions and fields on the way. So script statements. And then we have a bunch of different statements, so we'll switch on the statement. And this could be what the hell? Let, okay, I'll just rename this const decoration. Actually, this is not really. This could be both const and var. That's what's so weird about this. This is more like a, I don't know, declaration. What would this be? Like a binding declaration? Sure. Yeah, because it can be mutable here. Yeah. So binding declaration. Binding declaration. What the hell? Oh yeah, I need to dereference it. There we go. Okay. Now this could also be different, so you could we want to switch on the binding pattern, because the pattern can be, for example, it could be discard, which means that we don't really yeah, we don't have anything to bind it to. So also this is not how you do it, right? This is okay, well, whatever. But this is probably only this is the only thing that we can do right now. So if we have identifier, we can use it. There we go. So you easily get into these nesting situations in Zig. Okay, so now what we can do is we can say that now we have a field. Well, now we don't have a field. We have a declaration, actually. We have a declaration, and oh yeah, and we put the identifier dot name, and we put the value here, and the name is the name, and the oh my god, type expression spam. The type expression is gonna be the binding. Span is just gonna be a statement span. This is the annotation, so that's the type expression. However, it can be unknown, which I guess is fine. I guess we will make this unknown, and we have to deal with it later. Actually, here we could just say spam. All right, now if there is a duplicated field here, we can give a meaningful error. So we can say either we can put directly, we can also catch the error, and we can see that this could be, oh, it's just out of memory. What? Wait, clobbers existing data. Oh, I see. Okay, so we have to use like get or put. So let's do like get or put, and then you get the name out like this, and then here you can say like if entry is, oh, we have to do try. If entry found existing, now we have to return an error. So this would be like parse error, and then a duplicate struct declaration. Okay. Otherwise, we can go ahead and we can set the value to be this. And then we don't have this cache here. Right. Okay. So now we're taking all of our bindings and we are turning them into declarations. However, we don't have functions yet. So we also have to add a thing here for function. I'm not sure what it's called. So let's go here. Yeah, fn declaration. That sounds like something else in my language, because fn is stands for UN. UN declaration here. Very important stuff. Okay. So then this would be yeah, so then we have like a bunch of stuff here. So we could say we basically just, yeah, the declarations. Well, we can do the same thing here. Also, we're like zig. We don't support shadowing the scope here. Duplicate struct declaration. Declarations of functions has to have separate names, which is fine. Right. So that is the identifier. We might have to go through and see what we... Actually, this should be like in the arena. Yeah, all the... They should all be in the arena there. And then... if found existing, we do that. Otherwise, we will do value pointer, blah, 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 blah. Type expression. Right. So we might need to actually be able to refer to the function declaration itself. Like we do need to have like the function, you know, where the function is, like the function location, like the function definition, all the function bodies stuff. That should be part of this, so we know where to find it and how to execute it. This should also have like, you know, the value itself, the initializer. I'm pretty sure, right? Or is it enough with just a name and then we can look up? No, I think we need, because the declaration of a thing. Yeah, this is, I mean, okay, I think the function should be easy. I think the function is that could just be a pointer to the function declaration. No, but yeah, this could just be could also be just a pointer to the declaration actually. So declaration. So we could do like source. Declaration source or source. This could be, you know, union enum. So it's going to be like either a function, which is this pointer, or the other one, which is a binding declaration. I was thinking like technically binding could also support like functions, but yeah, you can have a binding that binds to a function. But yeah, whatever. We'll figure it out. All right, we'll probably need the source because we want to be able to find the like if we want to execute. Like we're going through lib, the import, which is a struct type, and we're getting the structure from it. No, it's a script, and then we get the struct from it, and then we want to call a function, so we need to find the function declaration and execute it. Or we're gonna rely on some kind of binding, which means we need to find the binding. Or okay, it could also be like in the scope you have now the struct, and the declarations on it will point to different things like functions and declarations. Yeah, this might be the wrong place actually. We might probably want to have this in the scope instead and not the declaration here. But okay, let's just have it here anyway, since we already have it here. So this would be like declaration source is gonna be a binding declaration, and it's gonna be S. Except we need this to be a pointer. There we go. So we get the original. Same thing here. And now your declaration source is going to be a function declaration, and that's also going to be S. All right. Name is this. There we go. Okay, so now we're building up we have all the declarations, and at the end we are going to, let's do like defer fields deinitialize, declarations deinitialize, and then we just we will copy them over here. So we will return this struct type, which has fields. It's going to be fields dot values, and declarations going to be declarations dot values, except we need to copy to arena first. Or try to anyway. And this is struct declaration. There we go. Okay, so we have a function now that turns a script into a struct type. Great. Now we're missing this here, but we can just say yeah, so let's continue with this part now. I think we could have like an empty map. Well, that's just I want, whenever I can, I usually want to initialize them like this. However, since this is a string array hash map, I guess is there an unmanaged version? Yes. Yeah, and then we can use empty. There we go. Yeah, because now we can just say empty there, and here we can just say dot empty. Or not? Yes, it has. Yeah. Okay. So now we can say like, now we can have a request document or something like this. And this would be some kind of path. And we would get, not the document, like request source, I guess we could say. And this would return the source. But the problem here, if we're gonna store the AST directly here without nullable, no, let's make this nullable. So if this is null, then we need to populate it, but we can still get the document out. Yeah, so let's just request the document, and we will actually get a pointer to the document. There we go. Okay. Now, first we need to then check. So let's get the entry first. So this would be, yeah, we need self as well. Store, map, get or put, and then allocator, right? So we could either pass the allocator here. Should we just add a like an arena here, I guess, maybe. But then we need to initialize, then we need to have an init function. Whatever. Yeah, it's unmanaged. Okay, let's just pass the allocator, whatever. Okay. Okay, the key is going to be the path. We're going to assume that the key is, or the path is absolute. Or we could resolve it. I guess we could have a resolve path function. If it's absolute, we just return duplicate path. Otherwise, we would return like current working directory, something like real path, something like this. Yeah. So this would take current working directory, it will turn this into a path, and it would also check that the file actually exists. If it doesn't, that there's going to be an error here, which can be good sometimes, and sometimes is stupid. No modular runic within modular runic. Oh. Okay. So let's do. actually, well, we're gonna do like resolve path. There we go. Right. So now the path is allocated here, and then we went deinitialize this. Well, if we're using like an arena, we don't really need to deinitialize it, which we are. But if we don't, then we actually, someone who uses this would have to go and manually go in and like deinitialize all the key or free up all the keys manually with this allocator that they used. But since we are, you know, we are actually just using an arena for this, then I'm just gonna say it here, made to be used by an arena allocator. Yeah. Or, yeah. It's kind of weird wording there, but anyway. Request document, yes, blah, 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 blah. So we have this entry here. Why do I have 3 different diagnostics for this one? So then we do a try as well. Oh, maybe that was why. Then we have the entry. If the entry already exists, well, okay, if we didn't find it, oops, we need to populate it. So the key, well, the key is already set, but the value, we have to now load the document. Actually, we need the path as well. Actually, what the hell? Real path. Does that give us absolute? Yeah, canonicalized absolute path name. Yes. Good. So this will make it into an absolute path. Then we can use it to load the document here with the absolute path. So we will have load document. We don't really need self. We need allocator and path. And this would return a document. Hey Zaflins, how's it going? Let's see. So this would then, yeah, now we need to like read the file and everything and return a document. Afterwards we just return the pointer to the document there. So now this function should be done here. The only thing we need to do now is like we need to read the document. So first we do file, no, we do open absolute path flags is read only. And there could be an error, so I'm just gonna do try here, whatever. Whoops. Okay. And then here we will say, so we have the file. Now we're supposed to read it. So we will say, we will just get the contents and we'll just read all. We need some kind of buffer, so I'm just gonna it's deprecated. So you have like reader, and then we have like read or take. No, wait, read. We have like interface, take, read, slice all. So this would be like that, but I'm contemplating whether I want to use like an array list or something instead. But yeah, just or read alloc, I guess. Length. Oh, I see. So we would have to kind of like have like a max document length. Now let's just have like, I don't know, 4 megabytes. This needs to be a pointer. I'm not sure if this works. I think you need to have like, you need to make a reader first. And then do this. Because otherwise it's like a constant. Okay. Then we get the contents, and then we will say, yeah, then we just return AST is null, source is that, and there we go. Yeah, and we also need to close the file. All right, so that now we've allocated the path with this allocator, and it's supposed to be, you know, the arena and everything, so it should be fine. Yeah, so we basically we can request a document if it exists. So it's kind of like a cache now. So if the document exists, we will grab it out of the cache, but if it doesn't exist, we will read it in, store it in memory. And then you would retrieve it. So you call this function whenever you need a document, and it's going to be cacheable, cached, memoized, basically. Okay. Yes. So in theory now we should be able to just pass the module, you know, the module path in here. And we can request this document here, and then if we want to populate AST, we get this pointer. We could populate it by parsing it and putting the AST here, and then we would have both the source and AST available. And if some other document also imports the same file, we can just you know, give it the same document. All right. Now, so we have documents. Now we need like an entry point. So instead of having source, we're gonna have an entry point, which is like the file that we want to basically parse. Or we could do that, or we could also like when we call parse somewhere, parse script, Yeah. When we call this, we don't actually have a source yet. What we will do then is we will have another argument here, which is gonna be the path to the file that we need to, that we're gonna parse. And now we can actually just say, hey, we might already have it. So if documents, request documents, no, first we get the document. And we're gonna use the arena allocator. So we request the document, and then we will get the path there. We'll do a try. And then if this document, well, now we have the document, but if the document has an AST, we can just return that, and then we're done. So now we have cache. Also, we've kind of memorized this function as well. But if we didn't have the AST, then we will say that this is the AST. Why is this like not working? Oh. I guess we can call it script. Okay. And then the document.ast is going to be script, and then we return the script. Okay. So now when we parse the script, it's also going to be put into this document map. However, this also, okay, I just realized that this doesn't really play nice with LSP. We would have to think about a way to make this work with LSP. Maybe we parse a document store, or we pass a document store maybe in here, and if we use that as a source for the documents. Because the LSP has its own store. Maybe, I mean, one thing you could do to make this super fancy is that you could make this a function. You could pass a couple of functions in here that would request a document, or request a source, like get source of a path, and then also like get the stored, like cached source or cached like AST. You could do that actually. I'll do it later, but I will keep it like this for now and make the execution work first. Okay. Now, we also need a way to like invalidate a document in this case. So, you know, if you would have an outside managed document store, then you would invalidate it using that. I'm just gonna add a function on this here to invalidate a path. Invalidate path. And we probably, yeah, we do need like an allocator, because I'm gonna use resolve path, and then we're gonna do document or map, and then remove. It doesn't matter the order, so I'm just gonna do a swap remove. Do we need to fetch it? Yeah, I think we need to fetch the entry because we need to... No, wait, we don't need to deinitialize anything. The arena is gonna deinitialize everything anyway. So but okay. No, but okay. The thing about this arena in Zig here is that if you free up something, it's not actually gonna give you it's not actually gonna give you more memory to use. Which is the weird part, because the thing is that it doesn't actually try to fill in gaps where you, like, let's say you allocate a block of code and then or a block of memory, and then you allocate some more memory. So let's say you have 3 blocks of memory allocated. So if you now free up the middle part, you will have a gap in the middle, right? And then you would assume maybe that next time you allocate something, it would look in the gap and try to fill that first. But it doesn't actually do that. It would just append to the end. However, if you free the sort of the end first, then it would free up that memory for you and you could reuse it. So if you want to use an arena and be very efficient with like freeing up, you know, the memory that you're using along the way, and then allocate more, freeing up, allocating more, using the same arena, then you actually have to free up the last items that you allocated first. So yeah, so that's how the built-in sort of arena works. And so if you're not careful, if you're using that and you're like, let's say you're allocating something, let's say you have a game and you have a game loop and each frame you're allocating, which is probably a bad pattern, but if you're allocating something each frame and then like freeing it at the end, make sure you free it in the same order as you allocated it, because, or the reverse order, because otherwise you would quickly run out of memory and you would get an out of memory error. Not sure how much sense that made, but anyway, let's just see here. So we have map, yeah, so we do like yeah, I think we just let's just do a swap remove. And the issue here could be that we're running out of memory at the end, because this is technically like a memory leak that we have here. Like we could once in a while maybe like deallocating, like duplicate everything into a new arena and then deallocate the old one or something like that. Just move to a new place, something like that, in order to like, yeah, reduce the amount of memory used. But let's just start here and we'll see how far we'll get here. So we'll do a swap remove. That returns a bool if it was successful. So that doesn't really matter. We don't really care. There we go. Also, this is error, so we have to try it. Okay. Now, yeah. Now we can invalidate things on the store. So let's say you want to update a document. Now we have to sort of, when we request it next time, it's gonna see that, oh, we didn't find the existing because we have removed it. So it's gonna load it all over again. Okay. Yeah. So now what? Yeah, And then we don't have to, the point of that was so we don't have to put any invalidation logic into the parser itself. It just handles some kind of caching system that we probably don't gonna, we're gonna move from this to have like you add functions instead that will that it will call. So I'm gonna show that later, but let's just see if we can make this work first. Okay, so we have a way to store the documents. Parse script now takes a path, and let's look here. So source we will like remove. I'm just gonna comment it out for now. We don't really need an entry point. That's what I was thinking before, but really we don't really need an entry point. We just need to keep this parser around, and then we're gonna call parse script on whatever files we found, basically, or whatever file we have. So the LSP will work a little bit differently than in that case. Well, let's not worry about the LSP for now. I think the LSP will just ignore that for now. But we do have this part, so I'll comment this out, and I'll just remove this for now. Alright, so the Lexer, okay, this is also something here, like the stream, the Lexer. So this would be, this is also weird now. The like, we will probably need like one per document. Actually. So that's interesting. Maybe we actually have like here we could maybe store like a parser per document, maybe. I don't know. Maybe we'll have a Lexer here instead of on the parser itself. So we would get the document. But anytime we want to get the Lexer, we're gonna have to request the document first and then get the Lexer from there. Maybe. I mean, I might be making this more complicated than it needs to. Okay, well, let's just do it. Let's just put the Lexer here, I guess. And this would be like, what, Lexer stream? And then you would just be, yeah, I guess we'll init with allocator. The source, I mean, yeah, we do have the source, so we could just do that. Have it the same order as the declaration. All right. So there's the Lexer. Do you have an error? No, you don't. Okay, cool. Now, the thing here now is that the parser needs to, we actually need to do this, and now we're gonna get a whole bunch of errors in here, and we're gonna do this, and this. Yeah, interesting. The stream is now like it's part of the arena allocator, so we don't need to actually deinitialize the stream itself. Wait, I thought I was getting like a million errors. Right? I thought this was like a super common pattern here. Yes, it is. So why am I not getting like a bunch of errors? Maybe it's too much. I don't know. I'm gonna implement these things so that we can, instead of using the stream, we will actually use this interface instead, so we can easily change this out. So whenever we have like stream next, I'm gonna do like next token. This is gonna be, I mean, we could even do self, and then this. All right. Oops. And the current token, yeah. And then here is like, we're gonna get the lexer from request document, or documents, request document. Oh man, we need like the, oh. Shoot. Okay, maybe we do have this, but it's like a pointer. And when we parse the script, we will, before we do this, so what do you do? Expected, oh, I see. Before we do this, we're gonna set the lexer or the stream to be document lexer. So now it's gonna refer to whatever lexer the document should have. Okay. Right. Okay. So let's see what is happening here. So I'm just gonna ignore the workspace here. Maybe actually I'll just do this to get the error out of the way. This will need a path, so I'm just gonna put this path there. Alright, we have, now we get a bunch of errors again. This one, and we parse. So here we actually don't need to load the contents. Well, okay, we are sort of doing it in steps here. We're printing. Okay, let's do this. Let's do, if we're printing the tokens only, we read it and then we print the tokens, right? But otherwise, we don't actually need to even open the file here. So we could actually put this in its own function. Make this a little bit more, oops, print tokens. And we need the path. And standard. I mean, let's just wait. Do we need standard for anything else? Are we getting it here? Okay, whatever. Let's just put it here. Oh, standard out. Right. Yeah, it makes sense. It does make sense. Okay. Now, where is the thing? Print AST, print tokens. So if we do print tokens, we do like print tokens. Return. All right. If we do print AST, we just do that and return. Let's see. But here we do parser, and then you would be path. Okay. And then we don't have contents. Or we might have contents, I guess. Okay, so we should get the document. This is kind of weird. Like the parser, the content should now be like part of the parser, I guess. It should be like current document, could be like instead of having stream, like we could have like current document or something. That would be like this. So instead of stream, we would have current document. And what is it? Parse script. Now, instead of setting stream, we would set current document to be the document. No. It would just be this because you are a pointer. There we go. And now there's a bunch of things going on here. So I just set you to undefined. Right, current token. Right, so now you would be like document instead dot elixir. Wait, no, current document. There we go. What the hell is this? Lines, okay. Yeah, okay, so this would be like current document. Wait. Yeah. Dot source. Yeah. Let's just do source. Alright. Now, parser error, the document. Right, because it's a stream. And parser init text. Right. And then parse file. You need wait, you don't need any difference. There we go. And what's going on here? Right, you need to be a try. You why is oh, we need a buffer, right? So let's just do, I mean, wait, isn't there like a buffered version or no? No, this doesn't make sense. Why would we need to put a buffer here? Wait, this gives you a file reader, right? Yeah. This does not make sense to me. But okay, whatever. Well, okay, maybe we do. Okay, maybe we'll do like this. Oh, there we go. All right. What else? Okay, so you out of memory. What kind of errors? What? Found. Yeah, so it doesn't say what errors are missing. Basically, we have to say something here. I mean, I guess maybe we just do this. That solves the whole issue, maybe. It might have to solve it later if we're gonna use it like recursively or something. No field name source instruct front end parser. Yes, no, that's correct. It's gonna be like, wait, why are we doing this like, oh, because of the log? Okay, I'll just remove the log down. There we go. Use of undeclared identifier contents. Right, so we don't actually need contents now. So I'm gonna remove that because we can get the contents from parser current document source. There we go. And wait, what the hell is this? Return 1. Oh, is this okay? I'll just return, wait, it's a U8. I'll just return this. I think this is just, yeah, we just return this. I'm pretty sure that's a U8 where we return from here. Yeah. And that would be like the exit code or something. That makes sense because we want to run the script and that also produces an exit code. All right. No field name stream. Let's do like lexer is parser current document. Lexer. There we almost go. parse script. I see. Here we don't actually have a path. I mean, we could. Okay. We could make a version that just parses source. I'm just gonna, you know, I'm not actually that much into the REPL stuff. I would just, you know, the REPL is not really prioritized. It was just a nice thing that the AI threw in there, so maybe we'll have, let's see how far we get, like parse source, I don't know. And then we have the parser, and we have some custom source. And we might get a script out of this. However, yeah, and then we kind of do this. Oops. And we'll do parse source. We don't request a document. We do this. We don't, well, what we could do is we could create, we could do like arena. No, let's do like allocator. See you later. Whatever. Let's just use the arena allocator, and let's do, because maybe we don't want to use arena allocator for actually things that are going to be deinitialized later and then reinitialized. I'm not sure. Yeah, that seems like a bad pattern for an arena. But whatever. Let's just do this anyway. So we're gonna do create a document, and then we are going to populate that, and the source is gonna be the source, the AST is null, and the elixir is gonna be like initialized. You need a source as well, I think. Yeah, with the source. And then we get the statements, we get the script, and we return the script. But then the source could be cast away, but I don't know. But whatever. Let's just do that, and I will use parse source here instead, and we'll just pass the source in there. Okay. All right. Okay, no more compiler errors. So what have we done? Well, we've adapted the parser to be able to store multiple documents now, instead of just having one source that we're parsing. So now we can have multiple documents, we cache them, we cache the AST, the elixir, and we also keep track of what the current document is so that we can print some debug stuff out for that. Now we also have to adapt the parser so that if we then, let's say we run, I don't think I'm gonna use the parser like this anyway. What I'm gonna do is I'm gonna have one parser, where the pattern is probably gonna be like this. First we want to let's say we execute the source.rm. 2 is that we create a document store. So this is from the point of view from the main program. 3 is that we parse source.rn, and we also provide the document store like facilities for that, which then parse will go ahead and parse this as store, like request this document from the document store. It will parse the file, produce an AST, put it in there. But then we also want to go through all the imports and parse those as well. So parse imports from source RN. So we need to like go through all the imports and parse them. So this would be like a 3A. Repeat 3 with each import. Right, so now it's recursive, right? In this pseudo language here. So that will parse every import ever that was from this entry point, right? Now the documents store should be populated with everything. However, if there is an error somewhere, we're gonna, this error like thing is gonna stack up here. So I think what we want to do is we want to have per file, a parser per file. That's what I think we need. I'm not sure yet, but I think we want to have a parser per file instead. Because it's kind of isolated anyway. Like the parser, like each file is kind of isolated, so we don't really need the context of every other file. Because it's not a semantic analysis at this point, it's just a syntax analysis. So we don't really care about other files. So each source could just be parsed with its own parser, which will make this a lot easier. We don't have to worry about, we do want to have some way of requesting documents and cache them, but we don't have to worry about, you know, having multiple errors for multiple like files and stuff like that. We're just worried about one file at a time. And it's not like when we encounter an import, we need to parse that as well. We're just looping through all the imports. So basically, like for each import statement, parse. Let's just do like do step number 3. Yeah. So that's gonna be like recursive there to do that. So here we like create a parser and parse source there with the document store. Right, so we're creating a parser for each import at this point. Yeah, that makes sense. And the document store, I will probably just, I will make this a, let's just make this a pointer then, so you could pass it from outside. However, I do want to adapt it also so that the LSP can use the parser with its own document type of document store, which means that we need to make this a generic, and we need to, or we could just have function pointers here. So we could just have the function pointers, like we could just we could say like request document, except it's gonna be more like get AST, get cached AST, something like this. This would be a function pointer that gives that you need like this is the key, the path, and then this would give us maybe a script, right? And then we would need And this could be part of the type, so you could put this part of the type as well, but I'm gonna put it as part of the fields now. Get cached AT. So we also want to get source, request source of this path, which will give us the source here. And now the lexer also makes sense to put in the parser, back in the parser as well. We don't really need to store the lexer in the document store. It's just gonna parse everything straight away, and then the lexer is just gonna be in here. So let's put this back here. The lexer. This is a stream, and well, I'll initialize it down here. Back here again, but we don't really have a source though yet, so actually I'll put this as undefined for now, and then when we actually call parse, we would populate it. Yeah, all right. And now we actually don't need this document store, but it will be needed from the script execution. But I want to adapt this now to this pattern instead, because then it could be, then it's like very generic. So let's see. So when we initialize, let's actually put these functions in here. So we would have like get cached AST and get source, and we put them here. Okay. And parse script. Now instead of doing this like the request document, we're gonna get the script. So, or we're gonna do if get cached AST path. Now the only problem with this approach, as I see it, is like if you want to have an error type, that's gonna be a little bit of a problem, because Zig needs to know what the error type is gonna be in comp time mode, and that's why it's a little bit more easy to put it in the type itself, because then you would know what the error type is. But if you put it as like function like pointers like this, and you want to have like an error type here, then you would need to know beforehand like which error type is gonna be. So maybe we just do this straight away. This is probably the better approach actually. So we would need two function pointers. Get cached AST. And now actually this would be a type. Or wait, hang on. Actually, it would be kind of like an any type, to be honest. Yeah, this would be like any type. And you would also be any type. So it's gonna be able to support any type of function, except, you know, it has to adhere to, it's kind of like an interface. But you kind of like, it's dependency action. And then we return a type. We're gonna return this struct, and now everything needs to be, unfortunately, indented here. I will do this. and we don't need you, and we're gonna do that. Gonna be a lot of cleanup here, and these are not used. So these are the function parameters. The thing is, like, if we attach a type to them like we do here, then we don't actually actually know like which function we're gonna use. So I have to put any type here. So we're not gonna have type information for them, but we're just gonna assume that they have the correct type. And we can use them here. We're not gonna do that, because now we can say try here to do that. So we can do try, and since this is like inferred, it's also going to infer the error type returned from this function. So we're not going to have to worry about, you know, the error types being wrong. So we get this thing. If we get the script, we just return this script here, because then it's cached. This could be handled from outside, but I think it's good that it's maybe in here. I don't know. Yeah, maybe this is like, maybe get cached AST is probably, maybe, you know, you could handle this outside of this, but whatever. Okay, so we're clearing expected tokens, we're getting documents, the statements. Wait. Yeah, so we don't actually have a current document now. That's a pain. Well, I guess we could just store the source directly. We'll go back to the source. Yeah, we don't have this. We have the source. I'm just gonna set you to undefined. It's just that it's undefined to begin with. And now we don't actually have. We could do source is going to be equal to get source, but it's not even self dot, it's going to be this. Yeah. And then this is going to be get source of path. Okay. And then, yeah, and then we do things as usual. We don't do this anymore. There we go. All right. Yeah, so I mean, technically we could have another function, like the caching could be, as I said, like kept to outside instead. Yeah, maybe that's better actually. Because yeah, then it's like every time you want to call this parse script, you would have to check, okay, do we have a cached AST? Okay, then we return that instead. Because I'm thinking, like, if we want to have this functionality here, we want to have another function where we publish the AST, and then we actually put this publish it here when we actually have it, so that the next time it's actually cached. So you could have like put cached AST, and over here we would do like try put cached AST script. Actually, we need path as well. There we go. So now we can sort of save it, and maybe even, but the another thing is like the arena, but I'm not gonna worry about that for now. We might just release the arena. I mean, we could always skip calling, you know, the initialize on the parser, and we could just take the arena and deal with it later, maybe. I don't know. Anyway, there's so many ways to do this. Let's see. Right, so yes, now we need to now support these different modes. So we have the LSP and the run script. So we have two different places where we need to fix the thing. So I'm gonna add runic parser. I'm gonna add documents to is this in front end or yeah? So I'll add that here. I'll just call it document. Okay, so now we should be able to get document store. It's gonna be document store. Okay. Now we're gonna make our own parser here. So parser run script parser, where we will put these functions here. So we need a function called get cached AST. Also, yeah, okay, another thing what we actually need to do is we need to provide a context as well. So here we have this, but we also need like the context, and this could be any type, which we will have to put into these functions. And this would be like presumably the document store. So that we can, because Zig doesn't have like closures, function closures, so you couldn't use that. But if we have like a context, this could be like the document store, for example, and then this would receive a path, and then we will return the AST. So this would be like the script. And so this would return, well, this would be like document. It's gonna be request document. Oh, of course we need an allocator as well. Sure, let's just add allocator as a thing here. Man, no, that has to be part of this actually. Yeah, let's just add allocator here, so we don't have to deal with this. And we actually need, now we need an init function instead. Whoops. Come on. Allocator map. No, we don't need to specify map. Okay, now this we could change this to self instead, so that we don't need to supply the allocator. This one we can do that. We don't need allocator. Load documents. Yeah, okay, let's not worry about the Lexer as well. Let's forget about Lexer. And you gonna be self document store instead. There we go. Back here, we don't need an allocator now. We can just do this with the path, and we should have gotten the document by now, but we might not have an AST, but we can just return the AST like this, except we need to do a try as well. So we will do this. Okay, there's the cached AST function, which we can pass in here now. And then we also need get source. And we need to put, and we also need to put cached AST. Let's do that one first actually, because it's kind of adjacent here. Put cached. So we had like context path script. Void, and we get the document, and we will set this to the script. There we go. And we need get source. Which returns this. So now we get the document and we just get return the source. There we go. Okay, so instead of parser, we're gonna use run script parser. There we go. So now this parser will know how to get our cached AST, publish it, and also get the document source. Now the only thing is left is the LSP, so I will just copy this, go to the LSP part. I will put this over here, and this is gonna be like the LSP parser. And this is going to be like Runic parser. Right, so we don't really have document store. We need to actually import that. And that's unfortunately in server. I'm gonna have to maybe move that. Document store is actually, it's not even public. Yeah, and now you are LSP parser. There we go. And here we're gonna do, so now we need to use these functions. We have open or replace. However, this is a bit more intricate here. Actually, so how do we want to do this? So we have update close get URI. Yeah. Because we only have path. Also, nothing here is public, so I'll just make this public. Open or replace, but we don't really have version. We don't have anything else. I guess we could put this to 0 if it's the first version. Workspace, we don't have workspace. Like maybe we should path, we do have URI, we should be able to calculate from the path. I mean, we don't have text because we're trying to open this, we're trying to read it. Oh, I see. This is if we already have text. I see. I mean, we could make a version that just reads. No, actually, we should already have the document, or maybe not actually. No, because the LSP client doesn't know which ones we need to import or check from the import. So actually, maybe we actually need to, here we need to have like the open file logic for the file. Like if it doesn't exist in the document store, I'm gonna do that. I'm gonna go down to the get function and I'm gonna make this public. And we're gonna do like try get URI, and we need to get the URI somehow, like and path could be absolute. Do we have allocator here? Yes. The path could be absolute, could be relative, it could be anything. Where was the thing? We have resolve path. So basically we do this. We do like resolve path or absolute path. It's gonna be this. Or we don't really need this. We can just say if it's this, it's that. Otherwise, it's gonna be this. Okay, now that should be. Oh, but we need to try now. Oh, need an else as well. I don't know what a good formatting for this specific thing is gonna be, but let's just do this. Also, this should be const. Okay, so we got the path. Now we resolve the URI, so we're gonna do format alloc print. It's gonna be self allocator. This is gonna be file, and then the absolute path there. And then we also free the absolute path. There we go. So there's the URI. And then wait, yeah, so now we got that. Now we can go over back here and we can use that to get the URI from the path, and we can get the document. If the document doesn't exist, we will return null, because yeah, this should really be nullable actually. It's kind of weird why this should also be nullable, because this type is nullable as well, or optional, sorry. Alright, now we don't really have an AST. But this would be like the document. And this document, this should store the AST here. So this should actually store the AST. Oops. Yeah. so we can return that. Why is this not giving me the return type here? Oh, because it's not a try. There we go. Alright. Cool. Then put cached AST. We are going to basically do the same thing. We get the thing, we get the document, and we populate it. There we go. And here get source. Yeah, same thing. Return. Actually, okay, not really the same thing here. If we don't find the document, well, if we find the document, we can just return why is oh, it's not, nothing is public on it, I think. But we should be able to get the text. Yeah, text. There we go. All fields are always public. I like that actually with Zig. I think it's super good. Why not? And I genuinely, I think it's really nice. They should keep it like that. Yo, Zeppelins, you're back. Where were you? All right. I need to eat soon, so I'm gonna take a. I'm gonna quit here soon. I'm a little bit sick today as well, but let's see. So I won't last for much longer here. Food had to be acquired. I see. Maybe I'll order something or something. I don't know. We'll see. Let's see. Whatever. Get source. Yeah, so if we have the document, we just return the source directly. But if we don't have the document, then we need to actually load in the thing. So we need to open the file. So we get the URI. We should probably have like resolve. Let's do resolve absolute path as well. Actually, we don't need that. We can just do like current working directory and then open from here. There we go. That should all like work for both absolute and relatives. We don't care about the flags. Defer, file, close. Try. All right. So now. Yeah, we want to do the same thing again. We want to do a buffer. Reader. And source. It's gonna be reader, read, no, take, no, wait, no, interface, read, alloc, the length, max source bytes. Where is that? Oh. Fine. We're mixing conventions here. That's the best way to do it. Alright, source is equal to that. Yeah, try, of course. So now we should have that. And then we just return that. Yeah. So the thing is, like, if we don't have it stored, we read it and return. The thing is, when is this going to happen? So this is going to happen if the document is not in the document store, which is gonna be it's probably not gonna happen. If it happens, it happens, I guess. And we close it. However, the thing is now that we actually need to take care of this leak here. There's a leak here. Thank you. Sorry, imagine if it was Rust. Well, I don't know how that would be, but yeah. I mean, technically, we could make a wrapper thing around this that maybe could solve that issue, but the problem here is that here we don't want to free unless we duplicate it. I guess we could, but that seems really bad. Here is like, okay, if we yeah, this is not gonna work. Maybe I will just do this, and I will say I will make an error here. I will just do an error document not found or something. Yeah. Yeah, parser is gonna be this now. Actually, let's okay, I know a trick. We'll do this. So now this refers to parser. Now we can say like self. Okay. And then you will be that. There we go. That's my special trick. Okay, expected type found. Yeah, so this would be like the LSP parser then. Maybe this should be exported from here instead. All right. Okay. Member function expected to arguments found 1. Yeah, you need the context. Where is the context? Context. I mean, okay, another way to do it. We can actually put the context here. So we can actually put the context here, but then we need to actually have the type as well. So we could have the type, the context type, and we could put the type there. And this could be, this is a pointer, and then instead of having to pass the context here, we can just do self.context here. There we go. And then when we initialize, we need to get the context. There. So now you are a document store. You are a document store. You need the document store. So we just need to create a document store here. So document store. There. And then I guess we don't really need to initialize it. Well, it doesn't have it initialized, so what we need to do is to create an arena, which will, so we'll need like a document store arena. And then we defer the initialize on that, and we put the allocator there. Okay, problem fixed. And then you need document store as the context. Okay. We get all these weird errors now. Get source. Expected 3 arguments. You need the document store. So where is that actually? Could be like self. No, we don't have documents here. Where's the documents? Oh no. Hello Polaris, have a nice day yourself. Thank you. Where are the documents? They are here. So, okay, let's augment workspace with documents. Wait. Wait, no, that's not correct. This is server document store. There we go. hang on, I'll get to it. There's so many things here. Get source. Okay. So we have store path. That's 2. And this is also 2. And that's 2. So why does it say 3? That doesn't make sense. Wait, do we have another function called getSource in here? Oh, you're saying, okay. I see. Thank you. Wait, this should be correct. No, get put get. Okay, yeah, thank you. There we go. And then the other one. Where's the run script parser? Same thing here. All right, cool. Thank you. Okay, now Lexer is just gonna be parser stream Lexer contents. All right. And then the document store. There we go. Okay. You need you, man. No. God damn it. I guess I could put it there. Whatever, I'll just hack it. Yeah, this is gonna be called straight over, like, anyway, so we're initializing that, that's fine. All right, what about this parser. This should be parser like this. You need like the button store, which we don't have. You don't have an allocator? Oh, it's self.out. And what? Oh. Parser. There we go. Okay, what's your issue here? Oh, you're a... No, you're not a error. Oh, I see. Wait, no. Just... I guess we just return. It's gonna be like an error, maybe. Document not found. Okay, and then back to this. All right. Oh my god. Missing struct field AST. Oh, well, okay, now that's easy. Just no. There we go. LSP server. Oh no. You know what? We're not doing this anyway. Well, we are kind of. Yeah, we are. Wait, are we? Man, this is... Wait, we have the workspace. Yes. Okay. Let's put workspace here. Wait, where's the... Oh, workspace. So now we can use no workspace documents. We need a parser. There we go. And now you need workspace. And you need workspace. Okay, now we're only down to these things. So this is just stream next. Peak. Stream current. Stream peak. There we go. We don't do this. We will do like self source. Source self stream equals init source, and then we don't do this. Is that it? Okay, I'm worried about parse script now. Maybe not, maybe I shouldn't. Yes, I should. No, because we set the source. We should, but we also need to set the stream. Yeah, we need to set this as well. There we go. Yeah. Let's put you there. Alright. Cool. Now. Awesome. Alright, so what do we have now? What have we done? We've made parsers being able to go get these functions, so now I can work with basically anything with this interface. Yeah, so it works both for the LSP and the script runner. Okay. I guess we can try the LSP out because it should still work as normal. So we'll do this. Oh. Okay, interesting. Sending diagnostics. One diagnostic. Okay, let's change it so it actually says what the diagnostic is. Let's do like JSON format. Whoa, that's a long ass file here. Something tells me we don't have billion. What is that? Trillion? Quadrillion? Quintillion? Sextillion? 7 lines? Okay. It's the source code of the universe. No. That's probably like 2 lines of code or something. Or 1 line of code. Everything is on 1 line. Document not found. Oh. And then these are... But why do we get like garbage here? Okay, that's bad. LSP parse file. So, I mean, we're doing it from within the document here, so the document should at this point exist, right? In the document store. Let's just double check this. I mean, we have update, and it should definitely exist. We have open or replace. No, yeah, we're putting the map here. And we're calling rebuild. I mean, technically, we could just put it. No, because this is a copy. I mean, we could do this. We could do put, like get or put. Because then we're dealing with a with the pointer to the actual document, and I will say so if we didn't find it, no, we're always gonna replace it with the text, right? So we're gonna say that the text equals text, the version, basically everything should be replaced. Yeah, I'll just put this to be document. Yeah, and then we do rebuild symbols. We don't do this. Yeah. There we go. Does this work? No. This was the one from before, I think. Yeah. What's the issue now? Segfault. I might have maneuvered myself into a maze of allocations and shit. Server, rebuild symbols, 36, collect symbols, segfault. Statement. Ah, the AST. Okay. Hang on. I kind of know what's happening. Question mark. So we run. So we have the parser. We don't want to actually. Yeah. When we deinitialize the parser, the whole AST also goes away. Like that's invalidated. So So actually, we want to keep the parser around until we, yeah, or at least the arena. But I'm gonna keep the parser around as well. Now this is the parser. There we go, yeah. And when we do this, we can release the old parser. If we have one. So if we have a parser, we will deinitialize that. There we go. Otherwise, we create a new parser, which we don't deinitialize. No, this just self parser equals that. You will go with that. What? No. Okay. LSP server, LSP workspace. Here's the same issue. So, but we don't actually do this part, I don't think. Or we do this part, yes, we do. But we don't actually use the documents here. So I don't think this actually does anything. Like, we get the script and we collect the symbols. This one actually dupes stuff, so I don't think this is an issue here. So I will just see if this solves the issue here. So let's do this. Let's remove some files or things. There we go. And we should get an... No. I'm not sure why we don't get the parse error here. Might be something with the clearing of the diagnostics, maybe. But we should definitely get a parser error here. Maybe. I don't know. Anyway. Import lib. Alright. So. It feels like we did a whole bunch of nothing, to be honest. But let's take a breather here and we'll gather our thoughts and position here and see where we can go. All right. Okay, we're working on the imports. Yes. So what we've done now is we've adapted the parser to work with, to be able to get like cached documents, publish like ASTs or cached ASTs, read source from a cached place. I mean, we could really have just provided that from outside. But whatever, the parser doesn't really need to know those things, but now it does. We could have just done it from outside, but anyway, it can do that now, and we have all that in place, all the caching and stuff in place, and we need that to be able to import more files, parse them and send diagnostics for them, as well as when running when executing the file, we also can do that. So for the LSP, I'm not gonna worry about the imports right now, but for the execution, I'm going to worry about it. So if we run print AST on this, there's a weird error going on. So this might be the same issue. Runic main dispatch run parser. Yeah, I think this is the same issue maybe, but here we're initializing it over here. That should be like the end of the program. Wait, failed to parse script is over here. This is handle this thing. Wait, what is the error? End of stream while parsing. Yeah, so I imagine this could happen if we yeah, if there's an error before we get the source. There's nothing depending on the source here. Oh. And then before we do this, end of stream while parsing. Oh, I see. Column 1, end of stream. Okay, so yeah, because let's see, where does this line come from? It comes from no, where? Okay, handle parser. Where was that? Right, it was here. And you're trying to read from the lexer. So the lexer was apparently not initialized yet. So maybe there's an error here. End of stream. Also, this issue here where you don't actually see the actual source function, so you have to know where it is basically. Well, you can do this, and you can do this, and you can do. Where is it? Front-end parser? No. Wait, where is it? Oh, here. Yeah. Okay, get source, quest document. So this could potentially then give us end of stream, maybe. Like presumably we're trying to read the document here, or load the document. We're reading this, read alloc. Hang on. Fill buffer with it. Invalidates previous return from peak. If the provided method camera with the end of stream is returns. Wait, so you can't be serious. It shouldn't be longer than 4 megabytes. Or wait, is it saying that if it cannot be filled completely? Right, so if there's like stuff left, we get an end of stream. Well, that's fine. Man, okay, take, is there like, I just want to read the entire thing and get a, like I wish there was a version which just give you an allocated slice but that has the whole thing. We have like short, returns number of bytes read, which is less if the stream reached the end. Yeah, that's basically what I want. I mean, okay, let's just do this. And then we have to have like a content buffer. This would be like bytes read, and you would be content buffer. That. Wait. Oh yeah. Okay. Yeah. There we go. There we go. It works. Cool. Now, okay, so now we have this import statement working. Let's go to lib. This shouldn't work though. No, because we don't have support for functions yet. So I'll just remove the functions for now. Oh yeah, you need to be like this. All right. Now let's just do that. Do that to make it fancy. Okay. Now this will pass the AST parsing. Okay. Now we'll go to run script. Okay. Now we need to just we need to just do stuff. So we're parsing the script. This is the entry point. Now we don't really have like semantic analysis, so we will basically just execute it line by line, and we will run the thing. So execute. Now, can you probably want, so we probably want to pass the document store in here. Holy shit, I've never actually looked in here. Or this, yeah, not much anyway. So we're going through all the statements. Handle the special statements. Yeah, we used to have import statements. Now we have like import expressions instead. So the import expressions are going to be evaluated as they go. So so we have like run statement, execute statement, execute expression. Yeah, it should be just an expression. Binding function and all that. So it should just be an expression. And we have these expressions, and we have like identifier, blah 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 blah. Also, we could have like a let, but that also ultimately goes into an expression. So we're at the same point here. So we have a literal. That's just one of these primitives. We have an identifier. Now that could call a command. It could also be like, no wait, this should be, we should know this. It should be like an import here, maybe. Yeah, we have an import expression. So actually we just add import evaluate import expression. And then import. And we will get like a struct here. Why do we get a value? What the hell is a value? Oh, what's this? Let's do this for now, and we'll see. Oh, everything needs to be a value. Okay, sure, why not? So we just have to support this thing. So this is gonna be like a type. This is gonna be like that. No. What is it? What is it? Is it front-end semantic? No. Front-end AST. Type description. There we go. Or we could have a special, maybe we could have like, instead of this, we could have maybe I don't know, some kind of table somewhere. We could have a symbol. This points to one of them, and yeah, something like that. I don't know. We'll see. Switch must handle possibilities. Clone. Well, it's just a pointer, so is this, do I have to say something like this to make this work? Yeah. No, maybe not. I don't know. Okay. Right. So okay, now we have all this crap as well. Materialize string. We could coerce the type into a string. We could do like a JSON. No. I'll just do invalid with types right now. Because we could have like a type, you know, stringify the type somehow. But let's just do that for now. Okay, how would we do this import now is the question. So we have some stuff in the thing here. We have an executor, we have a context, I don't know, we have a whole bunch of stuff. So we would need to, I think we need a document store somehow here. Executor. Context. What's this context? What the context? Run function. From runner, run, is this called somewhere? Yeah, init with runner, command runner, command executor. Okay, from runner, context is the runner. So that's the command runner, okay. Okay, so let's put the, okay, so this is the runner, encapsulate lower level mechanics responding instead of problems. Okay, I'm learning here how the AI built this here. Hi everyone, how's it going? Fun thing, I read my own language a few hours ago. Open YouTube, take a break, and history popped up in the recommendation. Yeah, welcome. What kind of language are you doing? Lightweight tracer invoked by the runtime made structure events during debugging pipeline execution. Okay, interesting. Again, error command spec. Run pipeline. Okay, here we can see like the innards of the pipeline stuff. Execute sequence of commands. Okay, we're going through like a loop, a running. Okay, so this is like a blocking, like it runs the first stage. I'm gonna guess this just this waits until it's complete. Maybe. Collect output. Yeah. So this is not really how I want it to work, but yeah. But all right, so this would need to be changed a little bit. Something between Rust and Zig. Oh, interesting. That sounds cool. Okay. Okay, but anyway, that's for later. I just want to be able to get so basically here, let's do some top down here, or whatever. So basically here, so what I want to do is I want to get the AST from this import. So we're gonna get the script. We are going to be able to somehow parse this file. Or parse module, let's say, because it could be like a special module resolution, module name resolution, whatever thing. So we get this module name. Of course, it's going to be a try. So let's say we have this script. Now we can say the struct. So basically, we just return type expression. It's gonna be a struct type, or wait. God damn it. It's called a record. Struct. And that is going to be well, this we had a function called like from or struct from script in front-end parser. Oh, that's the parser, right? So like, I'm just gonna say that we have a parser, and it's gonna be like struct from script. And that is the result. So this would be like evaluate, maybe like what happens if you import several times? Do we execute it several times, or is it gonna be something like we keep the result from the first evaluation? That is okay. I just looked at how Python does it, and they do that. They don't execute the same file twice. However, in Python, it doesn't really make sense to. Well, I guess you could have like another file. Okay, I'll show you what I'm doing. No, that's the wrong. Why can't it? Find it. There we go. I don't know why I'm getting these like diamonds and shit here, but let's see here. Lib. So let's do like lib2. So basically, what we have is I have like import lib2, and you can see here that lib. So this prints the main. So hello from main. And we have hello from lib, and then this would be like hello from lib2. Okay. However, I want to also import lib from here. Okay. Wait, where's hello from main? Oh, I see. So you can see here that like we import lib, that runs this. We import lib2, that will import lib and run this, but it doesn't run lib again. It just I guess it keeps the same like result. So I mean, it does make sense since you're doing like an import. You don't really want to execute it as a script at that point. You just want to import it to be able to use its utilities. It's kind of up to the programmer to like know what to do with this, but it's interesting when you have executable statements straight up in the file like this. So I probably want to do something like this, like keep the results in a something and use that as the result, like for a subsequent import. So yeah, I mean basically here we're going to like if we have a get cached module and we get the module here, we just return yeah, we just return that type. So this would be like type expression struct type module. We just return that. Otherwise, we parse it so path resolve module path we can just say parser parse script. But actually the parser we I think we want to make a new parser then. Yeah, okay. We'll do this. Parse file path. No. Let's just do this for convenience. Parse import module. We get the script out, we use it to build the struct type, and then we return that. And then this one will take care of like caching and everything as well. Oh yeah, scopes. I don't think scopes, like we're gonna have a new scope when parsing the module. That's not really gonna have scopes from before. So I don't think we actually need the scopes at this point. No. So let's just remove that. All right, now, yeah, we need to like do these things. Also, we probably need to get this module here. This is gonna be like module struct type, and this is gonna be like we get the module, and we probably don't wanna do this. We probably just have the struct type on the module itself instead. Yeah. All right. So, what is this? Evaluate the drive statements expression execution for AST blocks. It owns the allocator uses temporary strings and forwards pipelines to the command runner or any adapter implementing command executor. Okay. Interesting. And the module, like when you import a module, we're gonna execute, if it's the first time, we're gonna execute the module, or we're gonna execute the imported script. So the command executor needs to execute it, and then it also needs to, it needs the document store as well then, because it's gonna need to evaluate everything in it again. So ultimately I think this needs, we have the command runner. This is probably where we need to put it then. Maybe? High-level runtime components feed command through this tracks so the rest of the interpreter can reason about process handles instead of juggling. Maybe not. You're just running the stuff, so you don't really need to know about the document store. But you probably do, maybe. Or maybe not. Actually, yeah, maybe this is only for commands and not for like, okay, yeah, I think that's only for commands actually. Let's go here. What do we actually use here? What's the main thing? Script executor. Script executor. Script executor. Yeah, maybe this is where we put the document store. Command bridge. What is this? We have a runner, an environment map, allocator. We have some options. Context. We have the context here. Script content tracks bindings introduced by simple declarations. So future interpreter stages can reference them. It currently handles string literals, process snapshots, and module function aliases. Okay, this sounds maybe where we don't want to put it. Intentionally hides the backend storage. Richer value types can slide in later without touching the C-line harness. Man, you get so pretentious documentation here when you use AI. Okay. I mean, it's great. What the hell is a binding? Binding, value, mutable. Okay, that's just, okay, so that's a like constant or var, I guess, with a value. Okay, so this is the actual scope here. And then we have a function, binding, module alias, function name. Now this doesn't really make sense anymore. I don't think this, we're gonna use this. Because this was something that AI like cooked up a long time ago, like when I wanted to be able to reference like functions inside other modules, and it made this weird special case for binding to a function from another module, and that would be a special case for some reason. Okay, then we have like value. Yeah, this is what we had before. We have a type description is a string. Okay. Then we have an object value. Binding error. Yeah, I'm just reading this for the first time here because all of this is like AI generated. And I never went in here to do stuff. Declare string binding. Okay. Declare type binding. So we get a name type expression is mutable. Okay. String array binding. Like string array binding. That sounds so specific. Object binding. Assign string binding. Declare function binding. Declare function binding. Okay. Get binding. Right, so you would use this if you want to, if you have something that refers to something else, maybe. define binding index. Huh. So they have like unique names in this list of bindings. So this is like we only have one list of bindings. Okay. And then we check if the type expression is what we want, if it has the same thing, and then we return that. Okay, otherwise no. Huh. Yeah, this is so weird, like string array binding. So basically I had an example of what I wanted to have in the future features of the language, where I said that, okay, yeah, you're supposed to be able to define arrays like this. And that was an example of an array with, you know, strings in it. And then later, I think I just asked it to, hey, can you implement this? And I just selected the line. And it just went ahead and it it implemented specifically string arrays. That's so funny. Like yeah. You would think, if I explain to maybe, I don't know, non-developers, but to have, you know, it doesn't matter what's in the array. It could be anything. It doesn't have to be a string. Like, I understand if it's like very specific, especially with Zig, it's like, okay, it's easier to maybe think about. But you could put whatever you want in the array. It doesn't have to be a string. Would you need any other types? Yeah, I mean, for Bash, everything is strings anyway, right? Okay, so we've got like, yeah, all these kinds of bindings. The initialized value, okay. And then a whole bunch of weird tests. Okay, so, yeah, I just need to learn how this functions, really, in order to be able to like modify it to what I want to do. Competing as Bash, so it makes sense. Yeah, exactly. Maybe it's foolish of me to try to make other types than strings. Let's see. Okay, script executor. And then, so init with runner. So I think this is the function is calling basically. And so we have like a bridge, we have a scope stack, pushing a frame. Frame has, I guess, a bunch of bindings, yeah. And this is a different kind of binding. This is like, I don't know, this, okay, this has an actual value. And if it's mutable or not. We have refs. Interesting. Okay. And then we create the evaluator here. And we have a run function. Yeah, okay. What is this? Run with nmap. Specs, command spec, context. Patched. Spec. What is this? Oh, this is the end maps. Okay, I see. So bridge. Is bridge the like the caller or something then, maybe? Like the original context, whatever. Okay. And then we set every nmap to this, and then we run this pipeline. Right, so this just runs with pipeline, but this is only for like running commands. This isn't really for like importing stuff. However, what I will say that I want to be able to support creating a function in the language and then be able to pipe something else into that function and then pipe it to something else. So, and in that case, actually, this context would need to be able to evaluate stuff in the script and like in the language, and not only like command to command or like executable to executable. It's like each stage could either be an executable or it could be a function that's defined in the language. Is what I'm thinking we could do. So then this would have to know about the document. So maybe the bridge is gonna have, I don't know, man. We're running the pipeline, the runner, the nmap. Patched. What is this? This is a list of command specs. Okay. Run stage. So maybe at this point we don't really need a context, because we're just executing executables at this point. But later we will need some kind of context in here. I see. Okay. And here we have the evaluator as well. Right, so you have an executor. Interesting. Init with executor. Okay, so what the executor has a command runner. There's so many things that seems to be the same thing. I don't know. Evaluate the drive statement is special. Yes. Forward pipelines to the command runner. Okay, so this is. Init with runner, init with executor. Okay, this only exists in tests. This is actually not used. This is the one that's used. I'm pretty sure. Yeah, this only exists in tests. So what? So okay. Yeah, I think this is like the original thing. This thing here, this is the original. And then we made, and then it's like, oh, you need this feature. Okay, well, I'll make a second one called init with runner, and we'll just copy every piece of code in this version. That was the AI, by the way. And then this is the actual thing that gets like used. Okay, so we don't need to worry about this part, but I mean, it's probably very similar here. So we pass in a command runner, this evaluator command executor, right, and okay. I'm just trying to figure out like at which point, but it seems like everything is like, it's like almost like a cycle. The context, the script executor has the evaluator, and then we have a command executor, we have a bridge, the evaluator takes the executor, and then the executor has the command runner, and wait, where's the actual runner? Oh, that's in the bridge. Okay. So this one has the like the runner and the bridge. And then the runner has, okay, this has nothing basically. Run with runner. Okay, the bridge is created here, and that seems to be the only place where the bridge is created, I guess. I mean, we only have one evaluator, we only have one bridge, we only have one executor. And I'm just trying to make sense of where to put the stuff. It has to be just available to the evaluator, I guess. Okay, let's just put it here. Let's put it here. If we hit a roadblock or something, I'm just gonna, man, the time flies. Holy shit. I will just have to move it somewhere. So, okay. Module name. This will get us a module. Okay, we need to make a module type. That's gonna have a struct type, and this is AST type expression struct type. Okay. It's also gonna have like the script and the parser. Where's that front end? Wait, is that actually the parser we need? No, it's not. Where is the parser actually? Runtime? No. Oh, I see. It's in the like the command. I guess we could do like front end, document, store, and then the parser there. From there we can make like a, yeah, let's do that. Hang on, where's the... is. So I will actually move this to front end. Yeah. No. No. I will take this. Go to document store. Actually, we can just go here. And I will just paste this over there. Oops. All right. And now we can remove this. And we can go to run script. And you will be parser. All right. Right, so now you would be document store parser. There we go. Okay. Now let's put the modules here. So let's just do string array hash map. Modules, yes. Okay, we have that. Now, yeah, okay, so get cache module. So we will basically, we would just say, I mean, this is just gonna be like modules get. We would need like module key, resolve module path. Do like path. Let's do try. And I will return this, and this might not exist, so it's gonna be nullable. All right, that's that. Now we need a parse module. Module name. Which will give us a module. And do the same thing here, and we will get and we don't need to no yeah, so let's make a new let's get the entry. Let's do like self modules fetch wait, no, like get or put fetch put, yeah, No. How can I just do... Okay, it's gonna be get or put anyway. And this is path. Right. So now we don't care if there was something in there before, because I mean, okay, we could deinitialize it if something was there before, I guess. If something was found, we wanna free the key and entry value. We basically deinitialize that. Self parser deinitialize. Self. No, that should be it. Yeah. So we don't really need it. Okay. But this one needs to be mutable. So. All right. Yeah. All right. So after that, we will say entry key pointer is equal to path, and entry value is equal to so let's create the parser. Right, actually, let's do this. Let's create a parser here. And we need a, oh yeah, we need a document store. Whatever we should have, yeah, document store there. Should this be a pointer? No. Okay. But you need to build one. There we go. So now we have this parser. Now, we have the parser. You are going to be the parser. Right. So now I mean, we can get, for example, the script like this, right? And then we can say struct type is going to be parser struct from script. There we go. That should be fine. The thing we're copying here is either going to be like a pointer or like a non-array type, so this should be fine. All right. Where's the errors? What the hell? Runic parser script. There we go. Okay. Document store. Yes, we need document store. Maybe. Actually, maybe no. Yeah. We just make it here. Document store is equal to empty, or what's what we have. It's just gonna be it's init with allocator. Okay. All right. Frontal type expression does not support user menu. Oh. It's not gonna change anyway, so no field, no. Right. So we need resolve module path. Okay. And it's basically same idea. If it's not absolute, we will resolve it as absolute from. No, actually, this is not it's not the same idea. This is gonna be relative to. If it's relative, it's gonna be relative to the script file that we currently have. So actually, when we parse this, we need to know which script is importing it. So maybe we could store it in the expression. Importer. Yeah, so to be able to resolve the path, we need the importer as well. I don't know, there might be a better way to talk about this, but I'm just gonna shove it in here. Alright, now we have importer. Alright, let's just assume that that is absolute and the module name is not absolute, so we're gonna do relative. No, I mean it's just gonna be like a resolve or join. Right. member function. Oh. Whoa. Okay. So this one needs to also have parse errors. Because, yeah, we're not parsing until we actually execute it. That's the thing here as well. We don't form a tree of ASTs mapped to strings before we actually run it. But we should. So potentially later the parse error is not going to be part of this here. We're probably not going to parse it in the execution step. We're going to parse it before and then pass in the AST tree or the AST like the document store so that the evaluator could just get it from the document store. Wait, are we already doing that? Hang on. Parse. No. Wait. Run script. No, I don't think so. We only parse. Yeah, we only parse the one source. And when we encounter an import, it's just putting it in the AST. We don't actually parse the rest. Because what we could do here is we could loop through the script statements and we could like I mean this is probably what we should do, and then we check if this is an import or an expression, and we switch if this is if this is an import. And at this point, we parse that. Wait. Expression statement. Switch on that. Okay, now this is an input. So then we parse that, but we need to make a new parser as well. We need to make a parser per document. So maybe we should store the parser in the documents. Actually, okay. Yeah. Okay. So we don't actually create the parser like this. we will get like the entry document like this, and then we will say entry document dot parser parse script. There we go. Because now everything is stored here. All the parsers are stored there, so we don't have to manage those. Here we can just create new parsers willy-nilly. So we're basically import document. It's gonna be document store request module name, except now we need to resolve this module name here actually. So we're gonna move this to I don't know, module AST document. I'm just gonna put it here. Do we put modules there as well? I don't know. We need this. We don't need self, we need an allocator. Alright. And here we get the path is gonna be where's the aha, problem solved. Okay, then we do that. This should be a thing. No? Oh yeah. Well, we could do documents stored like this, I guess. Fine. Whatever. I mean, we can also do like documents. Document. No. Runic document. Resolve. Yeah, okay, whatever. So we have the path. We provide it here. The path is we need to delete the path. We also need an allocator. There we go. so nested here, but whatever. Okay, we have the path. We're freeing that. Now we're getting this document there. So this is the document. We are getting the script. So we're getting the import script there. Now this is the import document of parser of parse script. And of course we need the path there. All right. Then that should be the same. Wait. Handle parse. Oh. So now this should be like empty documents parser. Import document parser. Okay, so now we got the import script. So we just but the parse script actually publishes that to the cache, so we don't actually need this. Well, actually, no, I'm just kidding. We do need it because well, one thing that we actually do need is we need to make this into a function so that we can call parse imports from that. So we need like document store and script AST. Okay. So parse tokens or parse imports. Yeah. So we need well, we need an allocator as well. We need document store. And the script. Oh. And of course we also need that standard error. We don't need standard out. There we go. And then we will do the same thing here. So this is a recursive call. Allocator, standard document store, script, which is import script. There we go. All right. And you need some more stuff. You need allocator. You need use Neum and Quartz keyboard. Is it just a standard normal QWERTY keyboard? Yes. Swedish as well. So sometimes like the layout is not made for this keyboard. I can tell you that. Like the bindings. Some of the bindings standard. All right, and then we don't care about anything else. There we go. Same thing here. We don't care about anything else. Only imports. Okay, now we're going. Spoke too soon. Expected 3, arguments found 2. You need the importer as well. There we go. Okay, now try. Oh, stop myself. Expected type script invocation found that. Script invocation. Wait, why do you need that? you need the path. I think that's the only thing you care about. So right, importer. That we don't actually have, I don't think. No. So I will just do that again. There we go. Layout. Yeah, the layout is just a QWERTY. It's a Swedish QWERTY layout. It's a normal keyboard. No fancy, you know, split, whatever, this ergonomic, special kind of weird thing. Expected type. Found. Yeah. So you want the path, yes. So it's just gonna be a script. No, actually, you don't need. Wait. You just need a parser. You just need the parser. You don't need path. There we go. Same thing here. Okay. Return 1. So let's do like U8. And we return 0. But we don't actually return anything. I guess we can do like, I mean, this would just be an error. I guess we would just do like return error. And we don't actually return, whoops, here, whoops. Void. Try. So we'll do like, no, catch, return 1. There we go. All right. Man, time really flies. I'm almost up. All right, so I have like a couple more. Yeah, Vim is usually more US friendly, as well as, you know, the terminal. I mean, do you want to know how I did this? Shift 7. But I know in I can switch to, no, actually I actually disable switching layouts. You can switch in Windows pretty easily, but I disabled that because I didn't want to. But I know that you can just press. Yeah, there's one of these keys here. But basically, this is Shift 7, and then what else is like super annoying? This is also like Alt, and then the key that is to the right of left shift. At is Alt 2. Yeah, but there's a couple of ones there that is like super annoying. But it's fine. I've come to, you know, live with it. So if I want to search, I have to press like Shift 7 to search here. But it's fine, since I'm so used to it. I tried to change the layout at one point, and it was easier, of course, but I don't know. I don't want to have to live with 2 different layouts. That's gonna be too much brain power, I think. I don't know. Maybe it's easy to switch. No, I don't know. Okay, so now we should parse everything in one go. Like when we import the file, we should that should parse it there. So now in this file we need the document store. I guess we could now, this could be a pointer now, and we get it from here. Okay, then actually we need like a document store here. All right, and then we pass that, and you actually need to get that here. All right. I'll do that. That's fine. Doesn't matter. We don't actually have a document store here, I don't think. Maybe we do. No? We don't actually need one, to be honest, so I'm just gonna do that. Well, actually we might do if we want to support like import statements in the repo, which we probably want to do, but whatever. That's gonna be a ticking bomb. USA only needs to press Control-7 a slash above space. Yeah. I think it's my key is like this. No, wait. It might be this actually on the Swedish. This, I think this is. No, I'm pretty sure it's this. This is like the forward slash on the other one. I'm pretty sure. I don't remember exactly, but how the layout is like to the immediate, like on the, if you have the right shift key and then the key that is immediately to the left of that. Isn't that the forward slash key? So it's just one. It's just one key. No field or member function named resolve module. Also, I'm using the key arrows, the arrow buttons, the arrow keys for moving around. So it's kind of weird, but that's how I am. No field member function resolve. Yeah, okay. So yeah, we shouldn't need to parse the module. That's the whole thing. We don't need to do this. So I'm just gonna remove this, and here what we do is, yeah, we don't need to do this crap. And basically what we want to do is we want to Yeah, it's just gonna be like self document store, and then hang on. No, it's not, because we're gonna evaluate. We're gonna we're gonna execute the file as well. Stream somewhat low volume. I see. Okay. Yeah, I don't know. I haven't gotten that complaint before. Like on my kind of volume meter, it looks fine. Maybe it's a bit low. I don't know. Thanks for telling me. Maybe I can do something. I don't know if I could increase. Hello, 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 hello. Oh, is this the wrong way? Hello? No? Yeah, that's the wrong way. Hello? Hello? No, now it's maxed out, I think. Maybe? Yeah. Okay. It doesn't look like it's affected much. Yeah. I don't know. Okay. Let's see. Okay, I see. Yeah. We need to do, instead of this, we gotta do like document store, resolve module path. Right? No. Document. I'm just gonna import this straight away here. Resolve module path. Holy shit, what is happening? Oh my god. Oh, caps lock. Okay. Caps lock, like all hell breaks loose. Alright. What the hell? Okay, 1 second. There we go. Alright. Resolve body path. Importer. Alright. Now, what error are you expecting? What's your issue? Oh, it's the return type. Okay. Right. Okay. So actually, if we had a cached, we just return it. If we don't have a cached value, we need to execute the script. We need to actually execute this AST now, which is interesting here, because I'm not sure how. But if we go here and we look at the executor, Okay, we have a whole bunch of tests. Well, that's not the thing. Execute script. Maybe this. But then we need the executor. Why some functions got pub? Hang on, I'm getting a call here. Okay, sorry about that. Where were we? Okay, why some functions got pub but not all? So pub means it's exposed to files. So if another file imports this file, it will also be able to like access this function. If it didn't have pub, then it's like kind of like a private function, you could say. So only code within this file will be able to call this function. Sorry for the cliffhanger. Okay. So this this handles, this goes through the statements. I think this is the thing we want to call. However, we might want we might want it to be like in a separate executor though. So then it's possible to become global scope when referred to files. How do you mean? There is no such thing as a global scope in Zig. Like the only thing that is global are the special, like you have like import, like this is of course available everywhere. Oops, that's like the old. Oh, this is not the way to do it. Or this. So basically, you know, if you want something from the standard library, you have to do this. You have to do const and then some name and then at import stud here. So that's now you have the standard library in this kind of identifier alias here. But there's no such thing as global scope. The pub here means that it's like if some other function, or I mean some other file imports this file, it will be able to access this constant here, or this identifier here. But if it wasn't, you know, it can't access this one, for example. This is not public. Which makes sense because this is just a alias of this. So you wouldn't import allocator from this file. But you would want to import this one. Now, okay. Init with runner. Yeah, the thing is, like, when we import something, we want the scope is gonna like reset from 0. So we basically want an entirely new script executor, basically, to run the imported script. And then that will produce some kind of, you know, we would have all the scopes and everything from that script available to us. This should probably be part of the module. So let's say we have the module here. Wait, what the hell is this? Oh, this is some old stuff. Yeah, no, that's don't look at that. This is the thing here. So maybe we need like an executor, or this is like script executor. Where is this? Oh no, it's outside. What the hell? Script executor is common to have. mean, I'm creating a scripting language, so I mean this is okay. Preface. This is all AI is doing, but yes, I think you would need some kind of thing to like execute your scripts if you're making like a scripting language that I'm doing here. So basically it's just like keeping track of every you know, variable that you've declared and the values and everything. Don't need comments. Comments for what? You mean in here, like documentation? No. No, but yeah, I very seldom add comments, to be honest. Like I basically never add comments unless it's something that is I mean, in Zig, if you, for example, you returned like a string that needs to be deallocated, then I usually add a little comment that says that the caller needs to deallocate whatever. Otherwise, it's very, very rarely. It's basically only if I'm implementing something that is going to be used by other people, or I mean, even in that case, it's only for things that are not really the usual maybe kind of thing that you would do or see. I don't know. Like comments are it's good for, I guess, learning, but like if you're making a library, it's way more important. But if you're just if you're working like in a project, like in-house project, or you're working with you know, your own project like I'm doing here, then it's not as important. If you, it's like up to you if you deem it to be, you know, something that you usually don't deal with, then it's probably good to add comments to know, to just help a little bit the next time you go there, so you can like get back to, okay, this is how you do it, and this, like that could be helpful. And if you're making a library that others peoples are going to use, then it's very important, because yeah, it's the same thing. Like they wouldn't be, a lot of people would probably not be familiar with the interface, so they would need, it's always nice to add documentation to a library anyway, even if it's just a very common pattern. It's probably good to add good documentation anyway. And I love when there's like examples and stuff, but for like in-house projects, then I don't think it's necessary. And I mean, it all depends on, you know, the team and what everyone wants and everything, but okay, so this is a conundrum here. Script executor. I probably need to move this then into the interpreter here. Or another option maybe would be to have a have a function here that executes yeah, the execute statement. So this executes the statement. What if this is like a command? And then we just use the command runner, I guess. But the thing is, we need an entirely new scope and everything. Also, how does this work? Like we have frames, frame, binding, init, push frame, pop frame, declare, look up. So look up, find in frame. This looks at the... Okay, this actually loops through. So yeah. So you would get like if you would use the same scope and then push, yeah, this could if you would use this scope stack for the imported file, then you would get all kinds of weird stuff happening. So we would need an entirely new scope stack thing. Yeah, I'm probably just gonna... Well, here we have like handle special statement. I think this is how they did before, like how the AI did it before. It's like you had import statements and not import expressions. So now this is a statement, and now we actually go through and handle it here, like in the executor before. So this would execute the import. Okay. And here we get the import things, options. We have probably, this is like a cache for modules. And if we find it, we don't need to do anything. Otherwise, it's doing all this. Loading the source, creating a module, parsing the stuff, and appending the module. But it doesn't actually execute it. Okay, so it never executed actual statements. It just resolved values and functions. But what about values? Like it would have had to resolve stuff, like, because you could have a value that depends on some execution of an external executable. This is so weird how they did, how the AI did it here. Numeric. So, I mean, what about like a command? Would it just like not work? Okay, anyway, I was just trying to see if we actually have code for like executing the module, but I don't think we have. It's just doing like, it's just grabbing, like it's just like scraping the modules, the functions and values or declarations out of the import. That's what it did. So we didn't actually have that. Now the question is like, yeah, I think the simple solution maybe would be to move this to the interpreter instead, and then we could create an entirely new executor, keep the executor in the module itself, like this, and so we have the results and everything in the module. And if we need and then we don't wait, I guess some things would be passed to the context, like the environment variables, or probably, yeah, the environment variables we need to like put in this module. And this was a lot more than I was thinking it was gonna be. Okay. Man, okay, so we have this, we have this, we have this, we have this. We don't have this. This is what we're working on. Cache execution results, which I'm not sure if we actually need to have this for something. You know, it's just gonna execute everything as though it was the top file or entry point, and then you're gonna be able to access. Well, actually, yeah, we do need to, like, if you have values, we need the scope. That's what we need. Wire up scope to the identifier binding. Yeah. So the yeah. So if you, well, that's gonna be the scope. Yeah. And then yeah, we need to move script executor to the interpreter with code. Create one script executor for each import execute that is to be executed. Cache the result, wire up scope to the identifier binding. Yeah. Yeah, there's a little bit more things here. Pass and map, probably. So we would have like a tree of executions, possibly, and then the environment map needs to be like that. That is the only scope that is gonna be passed in there. But the variables and function scope, those are not gonna be passed to the imported script. Okay. Cool. Yeah, we've gotten a lot along the way and learned a lot about how everything works here. So I think perhaps, yeah, probably like next time we will be able to maybe tomorrow be able to like finish this off here. But yeah, very nice. Okay, but that's gonna be it for this time. So thank you very much for joining me here, and let's see if so that's gonna be it. So thank you very much, and I'll see you